Today, I'm redoing the Regex engine, but I'm gonna do it properly because last time it was a bit of a guessing game, right? I didn't really know what was happening. Now, I've got some clue. So I've been doing some planning. I looked at things. I did some research. Looked at some old courses I've done, and I've realized that I'm a big dum dum and that I need to do things using different techniques to what I did. Well, it's not strictly true. The passing part I think was a good idea. The passing I did last time was good, but trying to jump straight into matching was probably not the way forwards from there. So I learned about, or not learned, I should have known this already, but about NFAs and this thing called Thompson's construction. Basically, you take a regular expression and you build a kind of graph out of it, a non-deterministic graph, which lets you traverse through a graph that represents the Regex expression. And you can do something else. You can convert this NFA, which has like non-deterministic characteristics, into a DFA, which is deterministic. And it is by traversing the DFA that lets you figure out whether or not a Regex expression matches a particular bit of text. So in that sense, yeah, I had no idea what I was doing last time, but I think if I restart, I'm in a better position to actually do it properly. So I'm basically just going to start from scratch because I feel like looking at my old code, the parsing is very similar. The parsing plan I have today is very similar to the parsing I had before, but I just feel like I've changed enough of the structure, not a lot of it, but enough of it where I'm like, I think I'm better off sort of just taking the ideas of this, but then just going again. So that's what parsing v2 is for. And then, yeah. So yeah, a lot of this is going to be quite similar, but it's just going to set up the rest of the project. Trying to implement Thompson's construction algorithm and the eventual algorithm for creating the final DFA, the final deterministic finite automata. But yeah, this is gonna be pretty chill. So I've redefined my grammar. It's very similar to last time, but I've tried to simplify it and name things well because I think that was the major issue with last time. Like looking at block, I had no idea what block was. Like I kept forgetting what block was. Block was about the star, so I think all I've really done is just renamed some stuff, but try to make it a bit cleaner and like easier to understand. Just to go through it quickly, for any particular regular expression, we can define it as just an expression, but it's an expression that consists of a sub-expression and an OR expression. So what is an OR expression? An OR expression is, the pipe symbol with another expression. That's what allows me to have sub-expression or sub-expression or sub-expression, etc. Because I replace the OR expression, it can be replaced with pipe expression, which can then be replaced with sub-expression or expression. So like kind of recursively builds from there. Or expression can be empty if there is no pipe, or eventually we have to terminate. So that's like the base case. What is a sub-expression? A sub-expression is a star expression followed by another sub-expression. So that handles the concatenation operation. It's one kind of block, one star expression followed by another sub-expression. So that lets me concatenate two sub-expressions together. What is a star expression? It's a simple expression followed by an optional star. So an optional star is either the star, right, for 0 or more repetitions, or it's empty if there is no star present. So optional star is that. So star expression will have an optional expression. It doesn't always have a star, but it can, basically. Simple expression is either a single character, an escaped single character, because regex has instances of escaped single characters, or it is a grouped expression. So an expression that should be evaluated first before you kind of include it into the final regex. So like kind of the observation we had last time, the order of the operations is reversed to the order of precedence of this operation. So OR has the lowest precedence, so it's highest up, concatenation is middle, and grouping is the highest precedence, so it's lowest down. And then taking an example and just building a tree out of it. For example, if this is my regex, we start with the expression, and it builds into a sub-expression and an OR expression, because that's what the definition of an expression is, a sub-expression followed by an OR expression. In this case, the OR expression is empty because in the outermost layer, there are no OR pipes. There's no OR operators. There are OR operators, there's this one, but that's within a inner expression. So we don't consider that on the outside, on the outermost expression node. So this is empty. That's what the epsilon means, empty. Sub-expression is just a bunch of concatenated things together. So it's a, right, with the star expression. Notice that so OP stands for the optional part, so it's empty in this case. So, and the symbol is just the little character A. You have one sub-expression concatenated with another sub-expression, which is the B, followed by another sub-expression, which is the grouping of C or D and E and empty. This should be red. Right, so hopefully that makes sense. It's A concatenated with B concatenated with, in brackets, C or D and E concatenated together. And then that group thing together, which is this guy, is concatenated with something in brackets which has a star on it, referring to this star. Something in brackets which is F star concatenated with G by itself, concatenated with nothing. And so in that sense, similar to before, we can create kind of a tree structure out of a regex pattern. But the difference is, after we make this tree structure, we will be making an NFA using Thompson's algorithm, which I will discuss at some point. So as usual, I will not structure things correctly at all. I will have one massive main file and do everything in there and then split things up afterwards because my brain can't handle having multiple files. All right, so let's begin by hash including printing things and standard library and Boolean library. Yes, okay. We need one of these at some point, and we're going to need, what are we going to need? We're going to need all the structures. So these structs are sort of the same. And I feel like a lot of them, the structure of these structs are going to be similar as well. I'm not bothering with like the escape char stuff. I feel like I don't need to, and I'm not bothering with a star thing either. I'll just have a Boolean thing on the star expression. As in, star expression, like, sorry, I'm not bothering with the block thing. I feel like, I don't know, this was a bit of a weird roundabout way of doing what I wanted to do. So I will have a star expression, but it won't be just defined like this. It will be a star expression that has a simple expression associated with it and the sort of optional attribute, probably be an attribute associated with it. Okay, so let me see if I remember how to do this. So type def struct do I have to define it in reverse order? Because like sub expression sub or expression or, I feel like from memory when I put this into a head, yeah, I feel like I remember this being annoying. Like when I put this in a header file, it like came up with errors because it was like or is a keyword in C++, even though I'm not using C++. Is that true? Oh, maybe it's fine. I swear there was a thing. Okay, maybe not. Call this an expression. Does that work? Okay. And then hopefully if I do that backwards, everything should be defined in order. Type def struct. Whoa. Do I have to put a name there? I don't have to, right? More than one storage class may not be class specified. Interesting. Why is it like highlighting stuff? What's going on? Is this like Copilot? I don't know what's happening. So an or expression has an empty attribute, and then also has, this is really freaking me out. Anyway, also has an expression attribute. I do have to forward declare everything. Okay, because it's a bit cyclical. EXPR pointer should be pointers, shouldn't it? Because no way am I making copies of these things. Type def struct. Well, if that's the case, if I have to, I might as well define it in the order that it's like same order as the grammar. Type def struct. This is for sub, so this also needs an isEmpty thing, and then it needs a simple or something. Star. I guess I should say star expression. Star expression pointer star, and then sub. Maybe we'll be fine though, because I'm only using pointers, so we'll know the sizes of everything, won't it? So maybe I'll be fine. Why is this a problem? Expected a semicolon. Did I leave a semicolon out? What? I spelled type def wrong, that's why. Now I have to define this guy. Type def struct for star expression. What? Okay, star expression. I did it again. What was it? Simple and optional star. Okay, so instead of optional star, I can just have simple expression pointer, simple, and then also boolean has star. Last time I was like isEmpty, which was actually really annoying. This was a bad way of doing it. It's better to be like, I have a star, I don't have it, rather than isEmpty meaning I don't have a star. It's just a weird double negation thing that didn't have to happen. Type def. Okay, I need to learn how to spell. Type def struct. Stop. Simple expression. No, it's called simple expression. Simple expression, and it has a. Right, this is where the. Okay. So last time I had like a full-on enum that told me whether or not it was an expression type or a single char type or what. How do I want to do this? I guess I could do something similar. See, if you're using like an object-oriented thing, you can like do like in some inheritance stuff to keep the typing nice and clean, but we do not have inheritance. So I do think I need some kind of flag. So yeah, enum simple expression type. Simple expression type. Am I meant to? I normally use. Oh, I always forget how it works. What's the naming notation for when you use camel case? Do you have to like do this? Do I prefer that? I think I do. I might change it. Maybe I can use regex. Wait, let me try something. This is a bit off script, but I don't want spaces though. So not -s, yeah. And that's one group. Oops. How do I find and replace again? Is it like -1 expr? Will that work? Oh no. Okay, wait. This is such a tangent, but I just want to see if this works. How to find and replace regex groups with what is it called? Like capture groups? in VS Code regex. Oh, $1, my fault. Is that right? Okay, maybe this will work. Oh, it worked. Oh, but well, okay. Oh, but wait. Let me see if I can be better. There needs to be at least one character. So plus instead of, and then replace it with that. Okay, there might be a few mistakes, but it's good enough. Bonk. And bonk. Ta-da! Alright, I think that's better. I think I prefer that, just because I just find it easier to read if it's like that. Okay, so what are the different types of simple expression? You can have a grouped expression, commas, or you could have a simple char, single char. Do I want a separate one for escape char? Escape char, maybe? And then we can like do a switch case to handle each case. Okay. So we have, was there something like I'm supposed to put, to put scoping, right? So this is simple expression type. Simple expression type. Like you're meant to do like a kind of, I think it's meant to be always two. Maybe I'll say ST. It's like notation, convention, because there's no scoping in with enums, unfortunately. So you do your best to note the scope without being able to actually scope it. So simple expression type, and then what's wrong with that? Did I say enum? Okay, hang on. Type def. Put this guy down here. That should be better. Good. Okay, so we got the type going, and then we have what was it? Simple expression. Yeah. So I either have a link to an expression node, or so this is where the difference was. Last time I think I had one void data, like void star, right? To data, which was either this pointer or like I had a single char and like it worked, but I don't know, I don't think it's necessary. I will just have a char pointer called spelling, which will hopefully just mention as a string what the spelling of this particular simple expression is, if it's one of these two. So it'll either be, one character with the null terminator, or it'll be two characters, the backslash and the single character plus the null terminator. So, yep. Okay, so those are my structs. Oh. And then from there, I need to do the parsing stuff. So I have my structures, and I need like a expression pointer parse expression. Given, I guess, my regex, right? Char star regex. Maybe also given where I'm up to in the thingy-majiggy in the regex. Starts at 0 but increments along. I need to make enough space, size of an expression pointer expr is equal to that guy, expr or equals pass the or, given I guess the regex and the pointer. But first I assume we would have to do sub given the regex and the pointer. And I assume the pointer, this will probably have to be the address of the pointer, because I'm going to have to modify that as we go along. Okay, so if that worked, then expression, nope, sub expression, pass sub expression, given char star regex, and given int star pointer. Similar vibes, except sub-expression and sub-expression, and then a sub-expression has another sub-expression. Sub-expression consists of a star expression, so it's very similar. So this will say sub. I don't know, I did that. That was a bit dumb. Anyway, first you have to do star. So pass star. I should be returning stuff. Return expression. Pass star. I have to do pass or as well, don't I? Okay, I'll do that in a sec. Pass a star, so malloc star expression. I should say star expression. So star expression, first I have to pass the simple, and the idea is for checking if it's empty, after I'm done with all that, the pointer should be pointing to the next character if regex at the pointer. Maybe I need the length of the regex as well, actually. Int regex length. Just because for index reasons. Don't need all those commas. And then regex length. I've literally done this before, I don't know why I'm struggling. Fine. If regex at this pointer, so if a pointer is valid, is less than the regex length, and this guy is equal to the star character, then expression has star is equal to true. Else expression has star is equal to false. And up here we should also increment, I forget exactly which one happens first. Does the plus happen first? Probably not, right? But I'll just put brackets just in case. So yeah, we've set the pass simple, passing through the simple expression, and then we've checked if there's a star, and if there is a star, we've moved the pointer along. Otherwise, we've set it to false and kept the pointer the same. So there's no need to pass this because that's just looking if that's fine. And then simple, simple expression, pass simple, given the same stuff. So yeah, we have to decide. So if regex len, what if the pointer is less than that? So if the value, if the value of the pointer is valid index, then if that's the case and the regex at the pointer is equal to a thingy, then we should increment the regex. I mean, increment the pointer. I need to speak correctly. To increment the pointer, moving off the thing, we need to say, I need to malloc as well, actually. Give me that. What's wrong with that? Oh, I need to say regex line. Alright, we need to take this. We need to say simple. Take the simple. And if this is the case, move this along. Expression type is equal to, what did I say? Simple type underscore grouped expression. So it's that enum thing. Move this along. Expression maybe I shouldn't call it whatever. Expression is equal to pass expression given the regex length, and the pointer. And we can also say expression at the spelling, which is also a pointer, it's just null. So we set everything explicitly. Else if it's a backslash, then escape char, this is null, and the spelling, and then so we move the pointer along, and then we say the spelling okay, there's like weird things. Hang on. Do I want to do this using the string library? Because maybe that's easier. So spelling is, it's a backslash followed by, is this screwed up or something? Const char star. If I go like this and I go backslash followed by regex at the pointer, is that legal? Is that how that, can I do that? Or no? Like I'm trying to use like an array, but I don't know if that makes sense. No? Expected an expression. Fair enough. Yeah, I also expected an expression. Am I right in saying that this is like the guy who puts the string on the heap? Yeah. Yeah. Like I'm pretty sure that's fine. But my question is, what am I trying to do? So I'm trying to get the backslash and then the current character into the heap. Because string concatenation is a thing, isn't it? God, strings and C. What am I trying to do? I'm trying to get two characters and squish them into one string. Oh, God, I really have to. How to join two characters to form a string on the heap in C. We're really gonna have to. Okay. I mean, yeah, I guess I could have. I guess I should have. I think I knew that, but I don't know. Malloc size of 2, magic number, but kind of fair enough. Sorry, not 2, size of char. Yes, 2 lots of that. And the idea is expression spelling of 0 is equal to backslash, and expression spelling of 1 is equal to the current access character, because we've already moved it across. I should mention if this is not true anymore after the, if this is now greater than or equal to, then I should probably do like fprintf standard error in parse simple. Maybe I don't need to say in parse simple. Appears tried to pass an escape char at index, but and I will say the index value should be pointer -1, because that's where the backslash would have been, because I incremented already. Exit 1. That is my grand plan. Anyway, otherwise do that and then do that. Okay, and then yeah, that should be fine. Else, if, do it explicitly, else if it's a pointer like this, and yeah, that's it, don't need any other thing else. Else if it's a valid pointer, then the expression type is equal to simple type single char, and then yeah, I guess expression spelling equals malloc size of char. Feels weird mallocing for a single byte, but I guess I can't do much. Spelling at 0. Wait, it should be 3 because of the null terminator. And then expression spelling. That's what this was saying before, wasn't it? It was saying do 3. Yeah. Silly me. Anyway, if I'm going to exit 1, I should probably... whatever. So there should be 2 lots because of reasons. 0 should be simply the regex at the pointer, and then expression at spelling 1 should be the null terminator. And something I forgot to do each time is I need to move the pointer across again after I do the read. So you have to move across, you should move across because I just read this guy, and you should say if the pointer is less than the regex len, and no, if it's an invalid index or regex at the pointer is not a closing bracket, then fprintf standard error in parse simple tried to pass a grouped expression ending at %d, but seems to be unclosed. That is the opening bracket didn't seem to be closed by a closing bracket, and then we should exit 1. Fantastic stuff. Okay, so if I pass the entire expression, but it's not closed properly, then I should do stuff. Okay, cool. Else if the pointer is less than regex len and the regex of the pointer is a backslash, then we do all this, building the string appropriately, and then calling it a day. Otherwise, Else means we are literally, this isn't even true. It's not a valid pointer, which means fprintf tried to pass a simple expression. I should write the function name. Pass simple. Try to, but pointer appears to be invalid. An invalid index. And exit one. Okay. So we have all that. That's cool. And then if nothing bad happens, then we can just return the eventual expression. Oh, I didn't put a pointer. That's still wrong? What? I didn't put the thing. No, what? Oh, I didn't say standard error. Good. Okay. So we have all that, which is fun. Once again, I will probably try to build a little printing function so I can look at the tree, make sure that it looks correct. But yeah, I mean, that's all the grammar, right? Yeah. So yeah, I just tried to reduce the number of structs because I just feel like it was getting a bit weird. Do I capitalize? No, this is fine. I was going to say I thought enums should be capitalized, but I guess it's just the prefix I care about. It's empty. Sub expression is empty. Star expression has a star or does not have a star, which I did over here, right? If it has a star, then I'll mark it as a star, has a star, otherwise it doesn't have a star. Okay, so the real mistake I probably would have made is I probably forgot to increment the pointers in some places. In the really abstract areas, that probably won't need to happen because it's the lower level stuff that actually does the moving, actually reads the string and moves the pointer along. So the upper parts should be okay. Here we do check for the star, so we have to move it along if we read in a star. Yeah, so like here, for example, this increment reads in the opening bracket, but I need another one to read in the closing bracket, which is what this if statement is for. Here we read in the escape character, so we increment once, and then we increment again when we read in the second character. And then here we read in that one character by itself, so we increment, and then we have an error. Okay, so yeah. I shall begin. What I'll do first, actually, because I've defined these functions from most to least abstract, so I should probably declare them all. And I should declare them after I define my structs, shouldn't I? Otherwise, it wouldn't make sense. Bing, pong. All right. Yep. So, sorry. Pass the star, and then pass the simple. That's it. So, yeah, we had like 40 billion functions with last time. Oh wait, yeah. So we had one plus those, because it's that block and repeat it. Like it was a weird thing I was doing. This is just usability wise, will just be easier to work with. Yeah, should be good. And then, so yeah, I'll just see if I can build a quick print the tree given the expression node. Expression. So how do I want to do this? So from memory, last time we also had like a generation term, but we'll see. Was it like I had to make a pass, like I had to make a printing function for every single type, right? Was that right? Print node. Oh, okay, I did it like that. Okay, yeah, I did switch case. Oh yeah, I made stacks. Oh my goodness, this is more annoying than I remember. I broke it. I should change this back. Okay. Yeah, so what am I doing? Do I really want to do that again? Can I do it recursively? Well, the thing is, if it's void, if it's a bunch of void stars, then I have to cast it back. Because there's no way of knowing what type of pointer you have if it's a void star. There's no instance of or whatever that you have in like Java. Unless there is. Oh. I think it's genuinely easier if I make a print function for each type. So like print expression, void print, so I'll just do a little like border thing. So print expression, it's going to involve, sorry. And I think I will take a generation thing as well then. So yeah, I'll have like so void print indentation based on the generation value. And what I'm going to do is I'm going to say if generation equals 0, I could say if not generation, but I prefer saying it explicitly. I think I can just return. Or we just, oh no, what I did was I did print and then I said -d colon and then generation +1. Okay, I don't think I need to say that explicitly. Or int I equals 0, I less than generation plus I, print like a space or whatever, or a tab. I think tabs are too big. And then print this. So no need for the return statement, just do that. Because if generation is equal to 0, the for loop will get skipped, and then you'll just print 1 straight away. Okay. Yeah. Okay. So okay. So we have print the indentation given the generation, and then we're going to print printf expression node expression, maybe in like angle brackets, \n, and then print the sub expression given the expression's sub and the generation +1. I'm going to print the other guy, or expression, given the or, also generation +1. It's more, yeah, I think this is way easier. I don't know why I did like the other, I don't know why I did the stack thing before. Print the sub expression given a sub pointer and given a generation thing. Is there a way I don't have to do this each time? Probably not, right? Whatever. I've wrapped it nicely as a function. Printf sub, and then we have to print, what is the field called? Star. Print star expression given the sub star. If empty. If sub is empty, then return. Or maybe just print, yeah, that should be fine, right? Otherwise, print the star expression with generation +1 and print the sub expression with sub generation +1. and then void print, what else do I need? The or expression? Given an or expression, or, and a generation value. Do that, and then printf or, and then if or is empty, then it's return. Otherwise, print expression given the or's expression. Whoops. Expression and the generation. +1. Cool. I should probably put this higher up actually, because it's like, maybe not. Okay. Print star expression given a star expressions pointer and given a generation value. We're going to printf. Oh no, we're first going to print the indentation. Then we're going to printf star. How do I want to do this? If star has star, then we're also going to printf a space followed by a star followed by the \n, else and then printf \n. We'll do it like that. So if there's a star, I want to be like printf empty or something, or like none. I don't know. So I'm just indicate there's no star, and then star, and then print what is it? Simple star expression. Yeah, print simple expression given the stars simple and given the generation +1, and then print simple expression given the simple expression simple and the generation value. We're going to print the indentation given the generation value. We're going to print f simple. Okay, and then we have to like do this whole thing. If I think I won't do a \n yet. If maybe switch on simple's type pointer. And then case, what are the different types? ST. I think escape char and single char will be very similar. Can I scope this? Print f, or maybe fprintf fputs. Given the string, which will be simple spelling, and the file pointer, and then there was a break. Get out of this scope. Otherwise, if the case is st grouped expression, then we can say print expression given the simple expressions expression pointer and given generation +1, and then break. And if it's default, that shouldn't ever happen, but if it's default, then you can be like fprintf standard error. Some bad stuff happened. I should be specific. Print simple expression. Simple expression type not recognized, and exit the one. Yeah, and that should be it, hopefully. Did I \n? I did not \n. So I should do like, just put like some space here, put the spelling, put the \n. If it's a group thing, then just put the \n by itself, and then put the print expression, otherwise it's an error. Yeah, I think that's good, probably. Then I should put these as forward declarations as well. So print indentation, print the var, print these guys, print who, print or, did I forget to say void? Oh my goodness. Okay, fantastic. We have something. I also need to free everything. Oh, that's that as well. Shouldn't be too hard, right? Let me just think about my structure. So, you know, obviously the way that's being represented is not the same as the way I've drawn it in this diagram. It's a bit different. But essentially, an expression has 2 pointers that it might have to free. It has the sub and the or. The or might be empty, or it will have an expression. That is, if it's not empty. And then sub will have star and another sub, that's assuming again not empty. Star will have what does star have? Simple and optional. So optional star isn't really, it's just a boolean, so that'll free with the star. Simple though, so star cannot be empty, so that will definitely exist. Simple, it'll either have, so depending on type, it will either have an expression pointer, that is if it's of type simple type grouped expression, and then otherwise if it's of the other one, then it will have a char star pointer here. Okay, so that's my freeing structure, so we'll just do that quickly. So void free expression given the expression node. So we have to first free, the sub expression given expression sub. We have to free the or expression given the expression or, and then we can free this guy. Void free sub expression given sub star sub. Sorry, sub expression. We're going to freeze. What did I say? So if sub expression is empty, is false, then we have to free the star expression. Free star expression given the sub expression star. We should also free the sub expression sub, and then we should free itself, and then also free the or expression given or expression or. We're going to free if the or expression is empty, is false, then we're going to free the expression or expression, what? Give me the, there we go. And then we free itself, bing bong bing, and then void free star expression given a star expression star expression. Ugh. So star can't be empty, so we can say free simple given the star simple. Has star is not something you have to check, like we said. Yes, it only has one thing to free first, and then it can free itself. Void free simple expression. I really sort of switched around my naming conventions a lot. It's fine. So yes, like I said, switch, sort of a similar switch case. If it's one of these two, then free the simple expression spelling, that's the char star. If it's this guy, then free the simple simple expression, and break out. Otherwise, in free simple expression, this guy's not recognized, and then once all of those are done, we can free the simple expression. Wow. Okay. And then we need to declare all these guys. So I didn't say void. How many times did I not do that? All right. Let me see if I can. How to copy from Vim from regex match in VS Code. Alt enter, option enter. I feel like I've searched this up before. So I'm looking for void free blah to the end of the line, and I want to do, what was it? Option enter, and then I can copy, and then I can paste, but I need a semicolon. Wow, how exciting. And then, okay, so finally, I should be able to say expression star expression equals pass expression given the regex len and the 0. Oh, this should be a pointer actually. Okay, so let's do that first. I'm gonna need what is it, int argc char star argv, because it's an array of strings. That makes sense. And then if argc is not equal, what do I need to? Then be like, oh, fprintf standard error usage whatever the program is called, program followed by regex \n and then exit 1. Otherwise, char star regex is equal to argv at 1. So that's that done. And then int regex len is equal to strlen regex. So that's the second guy done. And then int pointer is equal to 0. So that's the third guy done. So we've got the thing, and then we should print expression, and we should, oh, sorry, of course. And the generation, which is 0, and then we should free the expression when we're done. Ta-da! And then if nothing bad happened, then we should be good. The fact is, I've written this before. And so surely I've been exposed to most of the bugs for the parsing, and so I didn't make too many mistakes. That's what we like to pretend. But in reality, am I in the right thing? Yeah, main.c. Wow. Did I not change the star? Oh, what? Okay, this is gonna take some time. Unknown type sub-expression. 16.5. 16. Ah, so I do need to declare everything beforehand. Oh, okay, that's annoying. Yeah, I think I knew that, but I kind of was hoping that wouldn't be the case. Damn, I thought if I knew the sizes it would be okay, but I guess you need to know the actual thing. 35. Okay, so I'm gonna assume that, yeah, it's okay. How do I do this again? So last time I like did all this to get around this, which was fine, it worked, but it was a bit annoying. I was kind of hoping not to have to do that. Let's try and do this trick, but alas. This is me just declaring the struct. Is that legal? That feels kind of weird as well. I swear you can do new lines in this. No? Ah. I don't know what I'm doing. Okay, whatever. Alright, whatever. Let me just try see if this works. Struct sub-expression, struct expression. So I got struct sub-expression, and then the other one, or expression. Struct star expression. I'm trying to get all the definitions up the top so that it recognizes the name at least. Struct star expression. Struct simple expression. I'm just worried because I feel like I don't have type defs and I don't know. Must use struct tag to refer to type. Yeah, that's why, because it thinks it's struct, so it's like you need to say struct. Okay, I guess I will do what I did last time. Big shame, but okay. So I'll get rid of type def all these times. It's going to cause a bunch of errors. I didn't mean to do it there. Struct expression. Struct or expression. Struct sub expression. Okay. And then basically just take all this, but only talk about the ones you need. Bing, bing, bing. I don't need that one. Need that one. Star expression. All right. Let's just see if that cleaned anything. Nope. Pass or. I didn't declare it. Pass or. Oh, I didn't even define it. Okay. Or expression. Int regex len. Int star pointer. So yeah, yeah. If the pointer is less than the regex len and the regex at the pointer is equal to the pipe symbol, then item malloc. Or expression star or expression is equal to malloc size of or expression. Then expression at is empty is equal to false. Would it be better to call it like for or expression? Would it be better to say if like is full? like again, like I don't know. I'm sure it's fine. So it's not empty, it has something in it, and then we need to move the pointer along, and we need to pass the expression at expression is equal to pass the expression given the same regex len, but a pointer that has been incremented by 1. Yes. Else, we need to say this is true. There's no need to increment, and that's it. And then we can return the or expression. And I should declare this. All right. No semicolon. What? 54. All right. I said print instead of printf. Good job, me. Yes, I did. Okay. We have an executable. Yeah, let's just pray, I guess. So a.out. If my regex is like ABC. Aww. Try to pass a simple expression. Pass a simple. There you go. Try to pass a simple expression, but ah, how intriguing. Or say equals, and then just put the pointer value in there. What did I say? I said, oh, I've done this before, so I should be pretty. Oh, there's no. I feel like I did the exact same thing last time. I didn't have a base case. I realized that basically I never actually do any checking to make sure that something is empty. Pass sub, like. Yeah, so what I have to do is if the pointer length is greater than or equal to the regex length, or maybe it's better to say less than. If it's valid, then we still have characters to pass, so we should do all this. And the expressions is empty should be false. I didn't do any of this. Else expression is empty is true. If there's nothing left to pass, then we've reached one of these empty sub-expressions. These two guys should be null. And then we can simply return, oh, it's already done. Yeah, so hopefully that's the reason. So yeah, it's just I didn't have the termination case when we reach the end of the string. Bing, very good. Oh, something broke. Freeing, I guess? Yeah, okay, so something's wrong with freeing. Okay, let me just look at this real quick. Expression sub star is none, simple as A, sub star again is none, simple as B. That looks right. Sub star is none, simple as C, then sub is empty or has nothing in it. Cool. Good, that looks fine. I messed something up with the free though. I will use the sanitizer in a second. I just want to check if I can just read it off. It's probably a use after free or something. Free. Check first you saw this. It's got to be a post traversal, so you free the two guys first, and then you free the expression. And then you free the expression or expression, then you free the or expression. Free the star expression, free the sub expression. That is if sub expression is not empty. If it's not empty, then there'll be stuff to free. Okay. Free these guys. Okay, free sub expression. Free sub expression, it's like, if it's not empty, then there's star expression and sub expression. Star expression, simple expression, check the type, free the spelling. Break. And in fact, if that doesn't have a break, then maybe the print doesn't have a break. It does have a break. I must have deleted it when I deleted the print statement. Okay, let's just see if that's the reason. Wait, did I delete the free? No. Okay, cool. I think that's why, yeah. So it would have cascaded down into the, and tried to access this, and what would that cause though? If it hit this case, freed this correctly, and then tried to access this, maybe this was like a garbage address, and then it was like, oh, you can't access that or something. I don't know. Anyway, seems to be working. Let's try something more tricky, like if it has grouping, or maybe not grouping, A, B, C, or D, E, F. A, then B, then C. That's wrong. Oh, it's literally this. It's the same thing all over again. I need to think about what a sub-expression can start with and terminate if... Okay. Ha. Okay. So a sub-expression can only start with a star expression. A star expression can start with a simple expression. A simple expression can either be a bracket, or it can be single char, or it can be a backslash. It cannot, for example, be a pipe symbol, which is what's happened here. It's thought that the pipe symbol is part of the thing. I literally have gone through this before. I've just completely forgotten about it. So past the sub expression, I can make a quick helper boolean valid substart given the int regex len, and given the current pointer. So it's just a random helper, and the point of it is basically just to say if the pointer points off the string, then return false, for example, right? So if it's off the string, then it's not a valid substart. Otherwise, if the regex at the pointer is equal to, for example, a pipe, or a pipe symbol, then return false, because that's not a valid start. Other invalid starts include stars, but in fact, if it's a star, I feel like that's really weird. It shouldn't start with a star, but nothing should start with a star. Like, none of these non-terminal should start with, oh, okay, that, but like, none of the ones I'm using in my code should start with a star, you know? A star gets tacked onto something else. If regex at pointer equals a star straight away, then fprintf, I'll do it to, maybe I will do it to standard output, I'm just curious what happens. Warning, valid substart, say warning, substart attempting to start with a star, returning false. I won't exit because I don't know if it's an error or what. Like, I don't know why I don't think this should ever happen. Is my point, but I could be wrong. I guess if it's bad input, then I guess anything could happen. I meant invalid cases, but yeah, in invalid cases, if you tried, like for example, if you were to do something like this, then you shouldn't really do that. If you're going to do that, you should escape it. Like that. Just escape and simple. But yeah. We shall see. Yeah, I would return false here. because it shouldn't do that. And then if it's a star, what other interesting characters? There's a bunch of others, you know, like brackets and stuff, but that's fine. It's allowed to start with a bracket, parentheses. It's allowed to do that. It's allowed to start with any character, any one of these. It's allowed to start with like a symbol, most of them. Quotes are an awkward one, but generally I think you escape quotes, but we'll ignore that for now. Any of these symbols, I think you can start. Oh, not that one, not that one. But most of the symbols, like exclamation mark, oh, even actually exclamation mark has some meaning in implementations. But most of the symbols you can start with, we'll keep it like that for now. If it's a star, a pipe, or at the end of the string, you should return false, and then you can return true otherwise. And then we can modify that function. I mean, we shouldn't have to, but we can partially modify that function if we need to. So then instead of this, we would say if it's a valid substart given the regex len and given the pointer, then do all this. This should be down here. Then you know it's a valid non-empty sub expression, and we should pass the star and pass the sub. Otherwise, it's not an empty. It is an empty expression. It's not a valid thing, so everything is nulled out, and then we return it. All right, let's try that whole thing again. I'm annoyed that I forgot about that. That was like the major bug of last time. Does that look correct? It looks pretty good. A, B, C, or D, E, F, or nothing. Cool. Alright, what else? Stars, I guess? A, B, C, star, so only the C gets a star, yeah, so you have A, B, and then C star. Good. Then what if I group it? What if I start grouping? B, C, star. So both the B and the C. Oh, boom, 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 boom. Okay, I know what's happened. Already I found an issue. Or regex star pointer is a closing bracket. It's allowed to start with an opening bracket, but for sure it can't start with a closing bracket. If I just read my old code, I'm sure I could actually like just see all these errors. In fact, maybe I will do that. Pass a pass. Look at the sub expression. So yeah, or closing star null. So those are the ones. Okay, so now I've actually done all of them. little bit too late. But anyway, expression sub star is none. You got the A. So A, and then you have starred, simple expression. So it's a grouped expression thing. Sub star is none. This is true because we're inside the brackets now. You got B, you got C, close it, or is nothing, and then or is nothing. Or because you've got an expression inside the brackets and then another or for out the outermost expression. Okay, I'm starting to back this. So I think I am able to quickly structure this correctly. So I will make an include directory and a source directory. Okay, what? Oh, I made a file, my bad. And a source directory. All right, so include, I'm gonna need some stuff, including basically the exact same files. Parser dot, what is, oh yeah, parser.h is the generic, right? Parser structures, we'll have a thing for that. And we'll just take all these guys. I'll take the enum as well, yeah. I might take all these libraries as well. Okay, so I've got all my standard libraries. I've got the enum for the types of simple expression types. I've got the different type defs for the structs, and I've got the structs defined beneath. Okay. Then I also need the pass functions. Now the only public function is the expression. So I'll just take that one. Do I really want multiple? I feel like I can get away with like just putting all in one, you know? Like, what if I just call this parser.h and just don't bother with like having such a verbose number of files? That doesn't make sense. That didn't make sense. See? It does make an error. It's like, oh, that's not legal because like or is a keyword or something in C++, so then it starts to complain. Let me change it here then as well so I can fix the error messages. It's a shame because, but what can we do? So every time I say expression.or, I gotta replace it with expression or expression. Bing. Like that. Let me just make sure I didn't break anything. Let's back out. clang. It's fine, I think. Also looks fine. Also looks fine. And I can't move it. Okay. So structures. And then passing functions. And then I need the print and then the cleaner, which is just this guy. Okay, so we have the three public things. I think all these structures have to be publicized so we can access the structure of the tree from wherever we want it. And then we need the source files. These I might split into functions, into files because parse.c. So all these guys, I need to take the rest of the passing functions, so not the top one, but everything else. I need to declare them. I also have to, I have to hash include. Is it relative paths? I forget. Does that work? Okay. VS Code is happy. For now, I am happy. And then I have to get all of. I have to get all of these guys. Pass. Thank you very much. Bing. So that's all the source code for that. Then we have to pass parser print. So once again, I'm assuming I have to hash include this guy, but I need to do all the printing functions. So I need to forward declare everything, but I don't need to declare that because it's already done. And then I have to put all the definitions. So print. No freeing, just printing. Did I get everything? Yeah. Bing. Very good. And then finally, I have to parser cleanup or free. Call it cleanup. Once again, probably have to get the structures of everything, and then we need to declare everything except the expression one because that's already declared. Bing, bong, bing. And then we have to get the function definitions, not the main, everything else. Free expression. Got everything, yep. Bing. Okay, we have all the definitions. I feel like my white space is bad, but whatever. Which means I don't have to do any of this, in theory. I just need to hash include hash include parser, and that will be enough to do some fun stuff. In fact, I would say the main function can be sort of in the outermost scope of the directory, like of this file, because like that's like the guy, you know, that's like the main guy. So instead of doing it that way, it would be include parser. How does this work? What? Wait, is that legal? Can I just do that? Interesting. Okay. Let me back out. And let me say clang. Okay, what I have to do, I have to mention all the source code that I want to use. Do I have to be like -I or something? -I parsing v2 include. This is my including library. And then I want to mention all of the source code. And then also main.c. Oh, it worked. I should get. Okay, so I think that should be fine. Cool. Okay, so yeah, that's my library again. Let me get rid of, I probably have, yeah, let me get rid of this. That's ignored, that's good. Okay. So that's my new library, my new parsing library. Very, very similar to the old one. Genuinely, probably shouldn't have done this as a video, but it's fine. Because now, I'm going to make the bold assumption that this is completely correct and that nothing bad will ever happen to the parser. And I will begin the Thompson's algorithm. What do I want to call it? NFA construction? Okay, so let's do some theory. So basically, what Thompson algorithm, so this is me like doing old examples. Okay, basic goal is to create a kind of graph that is capable of representing the regex expression, right? Specifically, an NFA means that a non-deterministic finite automata basically means that for any particular node, you're allowed to have, you know, some number of outgoing edges, but specifically, the symbol associated with those outgoing edges is allowed to be the same. In a finite automata, in a finite version of this, you shouldn't have that property. You should have each edge is a unique symbol, but why does it keep scrolling up? But in a non-deterministic version, you're allowed to have that. Also, you're allowed to have edges with the empty string, the epsilons, as a symbol on the edges. So, basically, if you see this graph as an example, one node will be marked as the starting node, like this. You can have multiple nodes marked as the finishing node, like as an ending node, terminating node, like if they're double circled, then that means it's a terminating node. And the idea is from the start, whatever path you can make, whatever word you can make using a path, any terminating path, means that that graph matches that string. And therefore the associated regex matches that string. So if you have a graph like this, then for example, if I start over here and I go, you know, empty string A, and terminate, that means that the string with 3 A's, the string which has 3 A's, A, is matched by this graph. And then the idea is, you know, the empty string also matches because you could just go empty straight away. You could go empty A, and therefore that would be two A's together is also matched by this graph. You could have four A's, 1, 2, 3, 4, right? That's you could have empty, then 1, 2, 3, 4, 5, 6. So that's six A's together that gets matched. So in general, the empty string gets matched, and then any even number of A's gets matched, and any number of A's divisible by 3 also gets matched. So that's what that blue thing says. But yeah, so what we're seeing is like, okay, we have this idea of regex where you're able to match some kind of set of strings, right, to a particular pattern. And then this graph is meant to do a similar idea. With instead of a string representation, it's a graphical representation of like what set of strings gets matched by the graph. So Thomson's algorithm basically is a translation algorithm that takes a regex and creates a corresponding or an equivalent NFA, non-deterministic finite automata. So yeah, how it works is there's only so many operations you have to care about, especially in like the basic version. You only really care about grouping operation, star operation, and concatenation operation. There's no real symbol for concatenation, so I just write the full word concatenation operation. So you have a few base cases, and then inductively you handle the operations. So base cases, if the regex expression is just the empty, if it's the empty string, then the graph you create is this, right? Because you start here, it goes to the end. The only thing you cross is the epsilon. So therefore, that matches the empty string, no problem. If it's a single symbol, like A, for example, you do a very similar thing, except the edge is an A, because naturally that matches the single character by itself. So that's cool. Now the inductive step, now this is where we handle all the operations. If the regex is, two sort of smaller regexes with an or between them, so R and S aren't necessarily individual symbols, they're just two regex expressions, or more specifically, they're regex expressions that you've already converted into graphs independently. So NR and NS are two graphs you've made out of the regexes RS and oh my god, sorry, let me say that again. NR and NS are graphs you've already made for the regexes R and S. So if your current regex is that R ORed with the S, then the graph you make is this guy, where this thing is the NR graph and this thing is the NS graph. This guy is the starting node of the NS, this is the ending node of the NS, this is the starting node of the NR, this is the ending node of the NR, and you make a starting node that links to each of the starting nodes of NR and NS, and then the finishing node gets linked up with the NR and NS finishing nodes with epsilons or empty strings marked throughout. And I don't know how obvious this is, but basically this graph will match both the NR stuff and it will also match the NS stuff, which is what the OR operator is for, right? Being able to match one, like being able to sort of loosely match either one in a relaxed way. Like, there's this path which is existing, and there's this path which exists. So both of these things will match with this graph, which is what the R or S thing is meant to do. So that graph works. And then in a similar sense, concatenation. If you have R concatenated with S, then you take the NR graph and concatenate it with the NS graph. Basically, the starting node of the NR becomes the starting node of the entire thing. Then the finishing node of the NR and the starting node of the NS kind of get merged together to make one kind of super node. And that becomes like the intersection between them, the connection. And then the finishing node of the NS becomes the finishing node of the overall new graph. And then finally, if you have a star, then of R, for example, not finally, but basically finally, if you have R star, you take the R graph, you take a new S star, I should say star here, hang on. You create a new starting graph, which links to the start of NR, and the finishing node of the NR links with the new finishing node that you create. Everything gets linked together with epsilons, and specifically, notice that there's an edge from here to here. which is epsilon. This lets you skip the entirety of the NR, because remember, R star means you're allowed to have 0 or more occurrences. So if you like, you're allowed to just jump over the entire thing. But if you want to have some occurrences of the NR, then you can, go through once, and then if you only want one iteration, you go to the end. Or if you want 2 iterations, you go through once, and then you go through again, and then you go as many times as you want, and then eventually you get out. And so that lets you have 0 or more iterations of NR or R in your graph, in your path. And so you're matching R 0 or more times. And then finally, is a grouped R, which is identical to the R. There won't be any changes. It literally will look like this. Like, there's no change. So in that sense, there's no point in drawing anything. There was this example I went through. I don't want to go through it again because, it took some time. But if you do work through an example, applying these rules, you can kind of see how everything falls out correctly and how the matching stuff kind of carries over. Pretty cool. Unfortunately, this is not the last step to making sort of a structure that you can match things with. After this, there is a way of converting an NFA into a DFA, but that's a story for another time. For now, I want to see if I can do Thompson's algorithm, basically handling each of these cases. And my prayer is that because I've constructed this tree thing, doing this won't be too hard. Because each subroot basically represents the operation you're up to, I know, for example, okay, if I'm up to a star, then I have to apply, I might have to apply, if I have a non-empty star, that is, I have a star, then I have to apply this case, for example. Or if I have an OR and the OR is not empty, I have to apply this case. Or if I have a sub and another sub and the second sub is not empty, then I have a concatenation case, So the structure that I've created is meant to, I did this with this algorithm in mind, which is why I try to simplify it, because I thought the old structure was going to make this really tricky. So that was the idea. Okay, so once again, due to my bad abilities, I shall do that. Make one massive main file. And then go from there. So what we're going to have to do is we're going to have to hash include the parsing v2 include parser. It's going to have all the publicly available parsing things. We're going to need int argc, int char star argv, and very similar usage. And this is practically the same. I need all of this as well. And then basically, we have to do this. And eventually we'll have to, okay, so it's identical. I could have just written it from here, but it's fine. But now the difference is I won't bother printing this, and we have to actually run Thompson's construction. So once we have gotten the expression node, I should have something that's like Thompson or Thompson construction. And then I'll pass in the expression node, and I don't know if I have to pass anything else, but then I should have an NFA star thing. So struct NFA. I don't really know what I want. I have nodes, I have edges, I have things like that. I guess I need a starting node and a finishing node. Oh, the other detail to mention is that by the construction of this algorithm, the graph will always have one start node. Well, there's always one start node, but specifically there'll always be one finishing node. That's not strictly the case with NFAs. You technically are allowed to have multiple, but Thompson's algorithm is defined such that you always have one. The base cases always have one, and then the inductive step, like when you have a finishing node here, for example, and here, you make them non-finishing and link them to a new finishing node. That happens in all the cases. Well, in this case, it's kind of a special case where this finishing node is still the finishing node, but it's also the finishing node of the entire thing, not just NS. And then this finishing node is like just an intersection node now, like it's a connecting node. It's not a finishing node anymore. So yeah, something to mention. So yeah, I guess I could have. So I guess I need a struct for like nodes. And from memory, the same thing is true with. No, that's not true. Sorry. Okay, so I need like. Yeah, I think a starting node would be smart. So I guess a node struct would make sense. And like something about edges, like do I need to, because like for example, this node has two edges going out of it. This node has two edges going out of it. I wonder if there's a way, I wonder if it's like capped at something. Like, do I know for sure that the number of, probably not, right? You can't know how many nodes are coming out of the maximum number of nodes. Is it always two? Looks like 1, 2, and then, I don't know. We'll be generic. We'll say, we'll just make like a dynamic array or something. I have that dynamic array library. I can use that. S is here, we link up. I do think that you could probably prove that the number of outgoing edges is always at most 2 in this algorithm. Because like, whenever you do the induction step, the new nodes on the original nodes never have any more edges drawn out of them except for this one. This one, I guess, the finishing node and the starting node kind of. Oh, but even then, you're not drawing new edges. You're just reusing the ones you already have. Here, you do have one more drawn. You have 1 and 2, but this was originally a finishing node, so it would have had no edges going. Oh, that's not true actually. Finishing nodes can have edges going out of them. But they never do in the inductive cases in this particular algorithm. I don't know. I shouldn't get too ahead of myself. Let's just be generic. So my basic thinking is when we handle the base case, for example, when we're up to a simple character, we're going to be making an NFA with a starting node and a finishing node and one edge between. The starting node will have one edge and the finishing node will have no edges. Then, that kind of thing will get returned up to a more generic case, up the tree, where, for example, we have A and B. First, we will construct the A, which will be this base case. Then we will construct the B, which will be this base case again. Then it will bubble back up to the concatenation case, where we'll take the A and take the B, and then the finishing node of A will merge with the starting node of B to make one node. So I have to sort of bubble up the tree. So how should I write my edges? Maybe as like a. Yeah, I guess just an array of pointers to other NFAs, or other nodes, I should say. Okay. How do I. It was my CSV parser, right? Which had the dynamic array library. So yeah, I'll just do like dynamic array and then just do that. Okay, so That's from the CSV thing, so I just stole that for myself. It's like using the macro thing, and it makes a very nice generic dynamic array library, quote unquote. Hash include. Is this the right file? Yes. Hash include. Get out once. Go into dynamic array, and then dynamic array.h. Okay. And then how do I use this again? Do I still have this open? Yeah. Okay. Wait, I forgot how this works. So you have to. Oh, I need guards. I need header guards. I'll do that in a sec. It was over here. Okay, so you have to declare dynamic array because that's something. Yes, that's the name of this. You give a particular type. You give a type which would be node star or just node. I think node star. I want pointers, and you would give. What is that? Label. Oh, the name of the array. Yeah. Node, and then edges. But that's like the type you're calling this array. Why is this wrong? Oh yeah, true. So I'll say struct node, or maybe type def struct node becomes node. Yeah, okay, good. And then you have a starting node, node star start. You have a finishing node, node start end, and you have edges, which is a dynamic array of nodes, which tells me what nodes we're linking to outgoing. Oh, and there needs to be weights. Ah, okay. So I should have a struct edge. So edge star. Type def struct edge. So an edge has a node. The neighbor. And then you should have a char spelling. Like the issue is I'm not sure if it's always necessarily one character. Like for escape characters, for example, might be / something. So in that case, you know, it's two characters. So char star spelling. What's wrong with semicolon? Are we happy with that? I think that makes sense. So you can access the edges. You can access the edges of a particular node, in which case you can see, which is an array of these edge structs of these guys, where you get a neighbor, you have the node, and the symbol that you're drawing on the arrow. Yeah, the neighbor that you're going towards, and the spelling of the thing. Should I call it like edge weight or something? Spelling is fine, right? Okay, so I have some structure. This is wrong. A node only has edges. Maybe an ID as well, or something. Struct, I think having a counter of the number of nodes would be good. And this is where I have a node star start and a node start end. An ID, because like normally when you draw these, I mean I used S and A, but like a lot of the time, especially when you have a lot of nodes, you number them just so like you can separate them. I mean for a computer maybe it won't really matter, but for me it just might be nice for printing purposes. So this is not called NFA. I have to type def a bunch. Hang on. Type def struct NFA becomes NFA. I'll do Yeah, I should define this. They kind of rely on each other a little bit. Just to clarify, when I use the dynamic array, field info, for example, do I make a pointer, do I? Interesting. Does that make sense to me? I guess so. Looking at this, it's just a struct. Like a dynamic array is just a struct. So you might as well get the address of that struct. So edges star. I think. Okay, so I have what I think is the generic structure required. And then we just have to traverse the tree and then do stuff. Oh my goodness. How am I going to print this out then? This is going to be way harder to print. It's not a tree structure, it's a graph structure. Maybe I won't print it. Maybe I'll just hope for the best. Okay. Let me think. Let me think very hard. So, we're going to have to traverse. So, we're going to need a bunch of NFA star functions to like translate expression, you know, which takes in an expression node and takes in, I don't even know, maybe nothing else. And I'm going to need that for each one of these. Translate expression, translate, oh no, I closed something. I didn't mean to do that. Translate expression, translate, or expression, translate, actually, that even makes sense. Sub expression, translate star expression, and translate simple expression. Okay, I'm a little bit, I feel like translate expression is actually going to be responsible for, the OR operation, but we'll see. Basically, here's my thinking, right? I actually think it's easier to start from the bottom, because that's like where the base cases are. Is this just saying this because there's no definition? Yeah. So NFA translate simply. If we start with this one, right? We begin by checking if, oh wait, I messed up. This should say simple, and this should say star, and this should say sub, and this should say or. Yep, simple, right? If, so we switch again. Where's my switch case stuff? Cleaning is probably simpler. Bing, bong. Okay. Expression, we switch on its type. If it's one of these, we don't free. Wait, why am I printing? That's funny. Don't need that. Okay, if it's one of these two, then it is simply the base case. We need to construct a new S and A for this kind of case. So, what am I doing? Come on, I can do this. Malloc size of NFA. Oh my goodness, I just pressed buttons for no reason. NFA star base case is equal to that, and then base start is equal to a new start, brand new start, brand new day. Malloc size of node, and then base end is equal to malloc size of node, and then base start edges data. Wait, what do I do? Oh, there are functions. There are functions. It's so this is a function called init, which lets you initialize the array, like the data, and lets you malloc it. Which I know how to use because you go edges init and then you give the capacity. I don't think I'll need more than. I really think I don't need more than 2, so I'll say 4. Wait, don't I have to like say? I feel like I haven't done this correctly. This returns the actual, yeah, so base edges, nope, base start edges equals this. Base end edges equals edges init. I'm pretty sure this is how you're meant to do things from memory. So we have that, and then the idea is I have to actually give one edge. I have to create an edge. I have to be like edge edge equals malloc size of one edge star. Okay, and then we have to be like edge neighbor is equal to the base end. That's where we're going towards. And the edge's spelling should be the same as the expression's spelling, because we know that we're in one of these 2 types, so we can just take that guy. This is all malloc, so it's on the heap. We can easily point to it. You know, it's not going to get erased until we free everything, which is at the very, very end. And yeah, that should be pretty fun. Actually, is that a bad idea? Would it be better to make a copy just in case if I want to free like this guy but not free the NFA, for example? Just so I don't like have all this stuff on the heap that I maybe don't need anymore. Maybe I will do. I do have this because I have the string thing already, right? So I can be like stirred up. Now I can use this function. The spelling's not going to be very big. It's going to be a character or 2 characters. So I think the copy operation isn't a horrible plan. I just think it's safer in terms of like not, because in case I free this, but then like, because once I do this, I don't think I need the tree anymore, but I might still need the NFA. So I might want to free the tree but not free the NFA. So if I'm relying on the tree to get certain bits of data, that might be a bad plan. Anyway, so we have the neighbors, and then the base start edges, and then we say edges append. I have to give the array, and I have to give the value, which is edge, because that holds one. Yeah, okay. I have some mild faith that this is correct. Some mild faith. Oh, I do have to think, if it's an empty string, what symbol do I use? Because I can't use like epsilon. So what would I do? Maybe oh, I can just do empty, can't I? Right? I can just do the empty string, like null terminator. Oh yeah. That was not as dramatic a decision as I thought. Anyway, if it's not that, and it's actually the grouped expression, then we actually just have to pass or translate the group expression. So we have to say NFA star, and I guess we can actually, here we can just return the base. This is the base case that we have to return. If it's a grouped expression, then we have to say the expression NFA is equal to expression. Maybe I shouldn't call it simple. Is that better? I think it's better to be more specific. Yeah. Okay. Oh god. Okay. Expression NFA is equal to simple expression translated. So translate expression, and I take in that, and I get that, and then I return. I literally, in fact, I don't have to save it. Return it straight away off the bat. and we got translate simple expression, and I should probably put the file name as well. Oh wait, NFA construction. Yeah, so the base case is handled, and you know, the grouped case is handled. So that's basically out of the algorithm. That should be basically this done and this done. The base case of it being the epsilon, I'm not sure if that will happen to me. I'm not really sure, but anyway. Regardless, let's go to the next layer, which is the star expression. So star expression. If it's a star, then we have to translate the guy inside, the simple guy inside. So we have to NFA star translate is equal to translate simple translate given the star, call it star simple this one. So we translate the simple translation. Now, if there is not a star, then we can just go, right? But if there is a star, if star has star, then we have to run this thing. We have to create a new NFA NFA, node star equals malloc size of star, right? Fantastic. We need a new end. Node end equals malloc size of end? No, what? Size of node? What am I doing? Wait, would that work? No, because it's a pointer, right? Anyway. And so we have the start and the end. And the idea is the simple translate. This is gonna get so weird. Its end, its edges should append this guy with the epsilon for an edge. Alright, so here we go. So we have 1, 2, 3, we have 4 edges to create, okay? 2 from the finishing node of the internal NR, and then 2 from the starting node. So let's do with the starting node first. I think that's a bit easier. Okay. So I should do the malloc, I should do the init thing first, right? Okay. NFA, I don't know what a good name is, base is equal to malloc size of NFA, and then edges init given a capacity of 4, we're going to say base start edges equals that, and base end edges equals this, right? So we have that stuff initialized. We should also probably initialize the actual start. Back Back. There you go. And then we should initialize the end using that as well. Okay, so I have the base, which is the overall thing. I spelt malloc wrong, which is fun. We malloc the start, and we malloc the end, and we malloc the edges that the start and end are going to have to deal with. Now, the... so... edge number 1... So the edge start edge 1 is equal to malloc size of edge and your star, and then start edge number 1, its neighbor we'll say is the simple translate. Oops. Is equal to the simple translate start, and the start edge 1's spelling should be empty. One byte. Is this wrong? Wait, what are you supposed to do? The count and the size. Is that fair? Just completely empty. And then start edge start edge number 2 is equal to malloc size of edge start edge number 2's neighbor is all the way to the end, is the finishing node, is equal to base end. It's the base end, the finishing node. And the start edge 2 spelling is equal to calloc. So that, and then from there, edges append, given the array of edges, which is the base start edges, append the particular edge, start edge 1 and start edge 2. So that handles the 2 edges that we have to draw on. Now from there, edge star. Oh, these names are horrible. Finish edge 1. The neighbor is equal to the starting edge of the simple translate, and the finish edge 1's spelling is equal to calloc. Edge star finish edge 2 is equal to malloc size of edge and its neighbor is the base end. It's actually very similar to this, and the spelling is also this. Edges append. So this goes onto the translate expression. Sorry, this goes to the simple translate end. The end of the simple translate. Its edges. Finish edge 1 and finish edge 2. I need to think of better names. Anyway, that's all assuming there is a star. If there is a star, we have to do all that extra work. And then we should return the base, which has all that extra detail. Otherwise, if there is no star, then there was no need to do any of that, in which case we return the simple translate, which is also of type NFA star, so that should work out fine. Good, fantastic. What a nice chunky function that is. There's going to be, I'll name that better, because I think I should. Okay. So we've handled that, in theory. So we've done that and that. So then we get the, this guy. So this is kind of handling the concatenation stuff, because sub has like sub. So we should translate the star so if okay, so NFA star translate is equal to translate the star expression given the subs. I have to check if it's empty. Okay. If sub is empty. The issue is if I return null, I'm a bit scared because like I don't really want to return null because I feel like my logic is supposed to be like I'm assuming okay. What if I just return like the empty NFA in the sense that like you have an NFA that is just like one node, start and finish, no edges. You know? Could that be a plan or? I'm really worried about memory leaks as well. I mean, this is a small enough program, it won't make a difference, but I'm going to say printf. This is NFA construction. Translate sub expression. Warning. That translate sub expression should not have to deal with an empty. So I'm going to do my best to avoid calling this function if it's empty, you know, like I'll just won't call it. I'll check if it's empty before I call this function. But yeah, I'll just return. I can't be bothered. I'll return null, but the print statement will be there to show that that happened, and I'll be like, that shouldn't have happened. NFA star translate. So you translate that. If sub is empty is not the case, so if it has stuff in it, then NFA star child sub translate is equal to translate sub expression, cheeky bit of recursion, given the sub. So this is what I mean, like I'll check if it's empty before I call the function again, hopefully. Child sub translate, and then we have to do a concatenation thing. So we're concatenating the star translate to the sub translate, I think. Now there's two ways we can do this. Merging, huh? So if we're doing a merging thing, it might be programmatically easier if I just make a whole new NFA with like 3 new nodes. That basically is a start node, a middle node, and an end node. That links everything nicely with that instead of doing like a merging thing. But it is a bit more verbose because you're adding 3 new nodes that you technically, I guess, wouldn't need to add. But I'm just trying to think, can I really just recycle these nodes? I have this guy and this guy as 2 separate, like what I have at the moment is S and A, and then S and A. So this is the sort of left-hand side, and this is the right-hand side. This is the star, and this is the sub, like this child sub, right? So I've got these 2 separate graphs, and I have access to the start, and the finish, and the finish. So what I could do is take all the edges going out of this guy and make it so that this person takes all of this person's edges. My concern is if this guy has an incoming edge, then I guess you would need an incoming edge. Like all the incoming edges that are going towards this S should be shifted so that they go towards this A, which I think is tough. So I think what might be easier is if I just create a sort of merging node, call it M, such that this has a new edge going out like this, and this M has an edge going like this. And then this S over here and if we make an NFA star, it has a start equal to this start, it has a finish equal to this finish, and then it has an M thing as well. So maybe I'd have to make 3 new nodes. I just make 1 new node. I think that's easier. So let's do that. NFA base is equal to malloc size of NFA. The base start is equal to malloc size of node, and base start edges. Wait, no, this is wrong. Sorry, what did I just say? The start is equal to the star translate start, isn't it? And base end is equal to the child subtranslate end. So the start of the overall NFA is the start of the left-hand side, and the end of the NFA is equal to the end of the right-hand side. So that's that. Those edges are already set. They would have been done when we called these functions. And all I have to do is say node star merge node is equal to malloc size of node, and then merge edges. Oh, the ID thing, I forgot about that. Ooh, okay, we'll think about that. Forgot, it's fine. Merge edges, edges init, given merge edges and a capacity, no. Of course, it should be equal to capacity of 4. I should really get rid of the magic number. I will do that in a minute. Not a minute, but eventually. Merge edges, go view that. And then the idea is, what did I say? So edge incoming star equals malloc size of edge, and And then the idea is the translate star expression, the star translate, your end edges, you should edges dot underscore append to this array, you should append incoming. I need to actually fill in the fields. Your neighbor is the merge node, isn't it? And then we need the calc thing. And your incoming spelling is equal to this calc thing. And then now you append it. And then outgoing the outgoing neighbor we said was the start of the right hand side, so it's the child subtranslate start, and the outgoing spelling is equal to the calc line, and we append to merge your merge edges, we append outgoing. So hopefully that means that we have created this edge and we created this edge, and we have marked the new NFA to be the guy that starts with this, ends with this, and has a merge thing in the middle. And so after all that, we can just return the base, because the base has been marked as the start and the end with this start and this end, with all this merging business in the middle. Now, if there is no child sub to translate, then there's no concatenation to do at this point. So we should bubble this back up to the tree by just returning the star translate. Good. I believe I have done good stuff. Star translate equals translate star expression. So we've done a bit of a merge. Yeah, maybe I can just, again, I've already checked it here. Do I want to be redundant and be like, if it's null? Then it's kind of, this should never happen though, because I've already checked if it's empty. I should be fine. Okay. So I think I've managed to do a bit of a merge, which is cool. Now the last thing is the OR. Actually, first things first, NFA star, I do think that this guy literally just returns translate expression if, and I will do a similar thing, if OR expression is empty, then I'll just do like a warning thing. Otherwise, yeah, just translate this one and get the graph for that. Get the graph, deal with it. Yeah. And then translate the expression. Alright, here we go. So we're going to begin by translating the sub-expression, which shouldn't be empty, but maybe I'll just check. If expression sub is empty, then return null. Would that ever happen? How would you get an empty sub? I guess if you just passed in the empty string? Or like if you maybe had like brackets with nothing in them, or a bracket A, B, C, or nothing, and then that's like A, B, C, or the empty string. So I guess it could happen, yeah. But do I want to return null? I think I still need a graph then. Maybe I do need to think about the graph you would make with the empty. But maybe I only have to do it here. Maybe I don't have to do it here or here. So return null. So don't return null. Return, what would the... Oh, right, it's what this is. Sorry, I forgot. That's what this base case is for. Okay, so if you have an empty expression for your regex expression, right? Can I do it this then? It's like a very similar base case. Okay, so you're making the base. The start is a node, the end is a node. You have edges with space of 4 available. You make one edge. The spelling is the calc line. And you append the base start and return the base. Yes, I back that. If it's not empty, sub is empty. If it's not empty, then we have a NFA sub translate is equal to translate sub expression given the expression sub. So you get that graph. If expression is empty, then I think you can just return the sub translate graph, no problem. Like that's just the graph. There's no or, there's nothing to do. Otherwise, the NFA star or translate equals translate or expression given the expressions or, right? So that will do this, which will just basically feed it back along to translate expression for the innermost expression or inner more expression. So now we have the left hand side, the right hand side, and we have the last sort of inductive thing we have to do. So we have bang bang and then two. Okay, this is easier than the merging. So we need to first make a new NFA base, which is equal to malloc size of base, and then what am I doing? Oh yeah, I need to make a start and an end. Base start is equal to malloc. Nope. Yes, malloc size of node base start edges equals edges init 4 base end edges. I need to malloc it first. Base end base size of node. Oh my goodness. Edges init 4. Now what? Now I need to do something with all that information. I need to make 2 edges for the start and 2 edges for those guys. Okay. How exciting. sorry. Okay, so edge start edge 1 is equal to malloc size of edge start edge 1. Your neighbor is equal to the start of the sub expression, sub translate start, and your spelling is equal to the calloc because it's empty. Edge start edge 2 equals malloc size of edge. Your neighbor is equal to the or translate start. So or translate referring to like the bottom graph. So the start of it should be the neighbor, and the spelling of that guy should be 2. Did I mess up? Partially. Okay. So your neighbor is that guy, your spelling is that guy, and those are the 2 edges you have to make. So then edges append, given the base start edges array, you want to append start edge 1 and you want to append start edge 2. So that joins this edge to this guy. Now edge finish edge 1. Your neighbor is the actual end, so it's the base end. And your spelling should be empty. Yes, and it should also be the end is there. And then edges append, so it's the left-hand side, the subtranslate. Your end edges should take in the finish edge 1, and the or translate, your end edges should take finish edge 2, and that should join that edge. So this edge gets joined when you run this line because the subtranslate is that top graph and gets joined like that, and then or translate is the bottom graph and you're joining that edge to which has that as the neighbor. Okay, I think this is correct. What are you for? You were meant to be way earlier. Why are you down there? Things get initialized. And I guess you just return the base, right? So in theory, I didn't do the ID thing, which means printing can't really happen anyway. But, the issue is like if I try to do a BFS or something, because there are loops, there are literal loops in these graphs, like with the star. There's like you can get stuck in a loop over and over again, like cycle. But I guess if you use a visited set, you should be fine, right? Oh, I need to actually give a What are the chances that this works first time? CD into NFA construction. CLang. I need to give everything. Do I have to be like dash I? Dash I. And then be like, give all the source code from the parsing. Do all that, and then can I be like main.c and then that's it? Oh, compiled. Oh no. Alright, it's way worse if it compiles straight away. Oh no way, nothing bad happened. Yeah, but I have no real. I don't know how I'm meant to. Oops, I didn't mean to do that. See, I can pretend that. I guess I could go through the debugger and like work with it like that, but that's pretty overkill. Surely I can. How do I visualize this? Okay, yeah, let's say I do a DFS. What would happen? I go here. Just to get some idea if I've gotten all the edges that I expect. So, maybe by randomness, maybe I would go all the way over here first and get to the finish node, then I'd come back, go over here, blah, 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 traverse through here, maybe go through the loop once. But see, this would be visited. But the edge would still be considered, it just wouldn't be traversed. So I could still print it as like I have this this edge. Okay, I need to do the ID thing. I need to do the ID thing. So I need to think about what my biggest current ID is and then add one to it so that. Yeah, I didn't fill in the num nodes thing at all. Okay, that shouldn't be too hard because it's inductively decided. So in the base cases, so this case, before I return the base, I can say base num nodes is equal to 2. But see, I need like a global counter, surely. Otherwise, how am I supposed to... Do I want a global variable though? Do I want like a parameter? But I'm not going to up... I guess if it's a pointer. Is this annoying? Is this really dumb? I just want a way to be able to keep track of how many nodes I've got in total. Because when I do this, I might be translating like a very... I might be translating an empty expression and creating this base case. But just because I have 2 nodes doesn't mean the ID should be 0 and 1 or 1 and 2. Like it might be 37, 38 because maybe I've created 36 nodes already. And this is just a very small part of a much larger regex expression. So I think I need to know... Yeah, I think if I increment it every time I create a new malloc size of node, like if I just do this, oops, if I just keep track of every time I've done that and just increment it every time, surely that should be fine, right? I also need to change the signatures. I've changed the signatures, so I need to... And then I have to pass in the pointer every time I call a thing. Okay. Fun. I don't know if I have to actually do that. I'm not sure. It's getting a bit crazy now. What was I doing? Oh yeah, IDs and stuff. So, um, base start ID is equal to, if I say equals to num nodes, and then I do plus plus afterwards, that will like increment after I thing, right? Which is what I want. And then similar sense, base end ID equals that as well. So this base number of nodes is equal to 2, but the total number of nodes created will be updated accurately, hopefully. And the IDs will also be unique across the thing. So long as, there's no more than 2 billion and something nodes, then I shouldn't overflow or anything. So 1, 2 is done, then there's 3 and 4. Base start ID is equal to that. Base end ID is equal to that. And then what have I done? So which one is this? Is this the... So this is the base case, and then this is the... This is like if there's no OR, and then if there is an OR, what do I have to do? I created 2 more nodes, didn't I? Base num nodes is equal to the left-hand side, which is the sub translate num nodes, plus the right-hand side, which is the org translate num nodes, plus 2, because I created 2 more nodes after I did all that. Created an S and an A. And then my actual counter is also accurately being incremented. Yeah? Okay. And then we keep going. So we've done that. So merge ID is equal to that. And the number of nodes is equal to, this is the merging thing. So it's the number of nodes in each case plus 1. So it's the left-hand side, which is a sub, I think. No, it's a star. So left-hand side is the star. Translate num nodes plus the child sub translate num nodes plus 1 because of that merge node. So we have 1 more than what we previously had. And then what's next? If it has a star, it's 2 more, isn't it? 2 more, 1 and 2. So base start ID is equal to this guy. Base end ID is equal to this guy. And then the base num nodes. So this was for the looping. It's for the looping, right? It's gotta be, surely. Yeah, you get the simple expression and you check if there's a star and you do the looping if necessary. Number of nodes is 2 more than the simple. So simple translate num nodes plus 2. Then simple translate is where the final base case is. So that's this guy. this base case. We do all that, we do all that. We put the spelling in, and the number of nodes for this particular base case is just 2. Yeah, that should be it, apparently. And I need to do a hash define. Num edges per node. I'm like pretty confident that I have to replace that with edges init with the constant. Quite a chunky file we have. Did I break anything? Okay, that doesn't mean anything though. But now at least I have IDs. So, yeah. So assuming that worked, should I just print how many nodes got? Maybe that's a good start. Let's print how many nodes there were. Print f number of nodes created is equal to num nodes. This is my first test. 2. That makes sense because it would have done the base case and nothing else. So that's encouraging. What if I had like AB? 5. Okay, so the reason why it's 5, I think that's right, because the reason why it's 5 is because you had 2 base cases, the A and the B, and then you concatenated them, which means you would have merged like that. So it'd been 1, 2, 3, merge, 4, 5. B should be here, not there. And this is the finishing node. So that sort of seems correct. Like, strictly speaking, that concatenation could be done with 4 nodes, but I feel like the implementation of that is, at least the way I've structured it, is difficult, so I just did it with an extra node. And yeah, that's I don't know. I should test this, but how do I print things correctly? This is where like knowing STL is like helpful. Unfortunately, I do not. All right, let's just do a BFS and see if we can like at least list out kind of the edges that exist and the nodes that exist and like that kind of thing. Hello. So yeah, if I okay, hang on. 1208. If I do a BFS, then that should give me a rough kind of idea as to what edges exist and what nodes exist that are sort of accessible and stuff. So, what am I doing? A BFS. So, I need a visited set, right? So I don't go onto. How do I do visited sets in C? For small enough examples, I could just do an array that I iterate over, but for a big enough example, hash table. Oh, they have IDs though. They have IDs, so I should be able to just. Yeah, that's fine. Like, that's easy. That's the other reason to have an ID, an integer ID, because then they become indexes for my hash table. Very good. Okay, that worked out. So, void, I guess, BFS, given the NFA. NFA source. I need Q though. Q is more annoying. It's probably a Q library already, but is a Q hard to implement? Popping from the start, right, is annoying. I guess I could wait. So Q means unless I DFS. If I DFS, I can recursively do it, and then because I don't really care about keeping things like shortest path or anything. I just we'll do DFS. DFS. We have the source and we have the just the source. Do I need anything else? Probably not, because I'm doing all the setup in here. So I need to make a visited set. So I should know the number of nodes actually. Oh, well that would be sorted. That would be stored in here, right? Source num nodes is there, yeah. And then visited isn't a boolean. Yes. Equals malloc. Maybe calloc, because I need to make it all false anyway, right? Size of. How do you? I don't know if I'm using. Okay, hang on. How to use calloc correctly? Is it the number of elements? Number of elements and the size of each. Okay, yeah, it is that. Okay, good. Number of elements. Wait, let me make sure I did that correctly. Yeah, number of elements and then the size of it. Okay, good. Number of elements will be num nodes. I'll say +2 for memes. And then size of each element will be size of boolean. Bolognese. So we have false, false, false for everything. And then source. Oh, yeah, I shouldn't take in. Okay, wait. An NFA is not the entire. Okay, hang on. Node star source is equal to the NFA start. That's what I was going for. Is that fair? Okay, so we have the visited set. We have the source node. I don't necessarily. Oh, but I need to make a helper recursive because this is the setup. So this is DFS, and then this is void DFS recurse. Given the visited. By the way, this should be bool star. Why didn't it give me an error? Bool star visited. I need the source, so node star source. Is this fair game? Okay. And then basically, if it's already visited, if visited at the source ID, then I can return, right? DFS means if I've already visited, there's no point in you've already done all this process, so you might as well. Otherwise, now we mark it as visited. When you pop off the stack in DFS, that's when you mark it as visited. So yeah, when you pop off the stack, that's when you mark something as visited. So visited at the source at the ID is equal to true. And then for each of my edges, oh, I don't have a counter. No, I do, because the dynamic. Oh, that's clutch. The dynamic array tells me how many elements are there. Okay, that's lucky. I forgot about that. Okay, so for int I equals 0, I is less than the source's edges size. So capacity tells you how many can fit, but size tells you how many there are. Plus I. Printf edge exists between node %d and %d, and where %d should be firstly the visited, firstly the source ID and also the, alright, here we go, source edges I, that gets you the particular edge, neighbor, wait, what? Wait, what? Oh, my bad. Yeah, sorry. You have to get the data first, then get I, and then get the neighbor, and then get its ID. Accessing this edges, accessing the actual array, because the dynamic array has 3 fields. One of them is data. That's the actual array. You index it to get the particular edge you want. You access the neighbor because that's the node that it's leading into, and then the ID. So I shouldn't just say exists between. I should say goes from node this to node this. And then I can say DFS recurse given this new node given this guy and given the visited thing. And that should hopefully print out all the nodes and all the edges that exist via a DFS. So everything that I can traverse through. And hopefully that means every edge and every node gets visited once, and so I shouldn't get stuck in any loops or anything like that. And then I call DFS recurse, and I say the source, and I say the visited, which is a bunch of false statements, and then hopefully all the printing happens, and then nothing bad happens. And then I say DFS, given the NFA, and I run all of this, and then I run this, and nothing bad happens. I should indicate the spelling as well, actually. Edge spelling equals %s. Apparently you're not meant to use %s or something, but right now it's okay. Data at I spelling. Didn't compile. Okay, what I will also do is I will say in the DFS, I will say printf source node equals %d, which is, and I'll do 2%n, I'll do 2\n, source ID. So if I were to draw this out, just sort of naively without thinking too hard, I would say the source node is 0. That makes sense. Edge goes from 0 to 1, so 0 to 1 with a weight of, with a thing of A. Edge goes from 1 to 4 with nothing on them. 4 goes to 2 with nothing on them. And 2 goes to 3 with a thing of B. And this looks quite right. So the reason why it's numbered weirdly is because this 4 got created after this 3. Because remember, what happened was, inductively, this guy got created. That's the base case. Then this guy got created. That's the second base case. And then 4 is that merge. I shouldn't have double circled it. 4 is the 4 is that merging node for the concatenation. It's the M guy, right? So it took, those are the 2 base cases, and then it took these 2 guys and then made a merging node between them that went like this. And in this case, because we made you know, the most recent number we used was 3, so the next one to use is 4. That's why it's like that. So that's quite encouraging. Seems like I didn't completely break everything. I still need to free stuff, but luckily I think if I do DFS, you can free via a DFS, right? You can go along and free everything, but it's a little bit awkward because there's a lot of malloc things. But yeah, that's basically the idea. What happens if I put a star in there? Then there's going to be some loops. Ooh. That could be me forgetting to calc. That could also be me, that could also be something else, but I'm not sure. there are 7 nodes, which again maybe sounds about right because the star would add sort of 2 more nodes from 5, but why is it null? Wait, so maybe I'll draw it first and then we'll see what happens. So again, naively, 0 to 1 with the spelling of A, I assume, yeah. And then 1 to 6 with nothing on it, 6 to 4 with nothing on it, 4 to 2 with nothing on it, 2 to 3 with a B, oh whoops, 2 to 3 with a B, so that's the 2 base cases we've seen, 3 to 2, oh, that's the loop, that makes sense, 3 to 5 with nothing on it, and 4 to 5 because of the skip. That looks pretty good, but I will bear in mind that 3 to 5 has a null on it. So my guess is I forgot to put a calc for this edge, which would be so in the looping, in the translate star expression, there would be a finish edge 2 or something. There you go, that's why. I spelled finish wrong. So if I try that all again, yeah, no, there's no null. So that's a problem because that's the only thing. I feel like the way I wrote it was a bit brittle. Like I feel like I didn't really write it very well. Especially I think what I could do, considering that this is quite repeated, I could make a function that draws an edge between 2 nodes. So a helper function. I should have done this earlier, really. I should have seen this earlier, but I don't know if it needs to necessarily return anything, but some kind of function, which I'll say void for now, I'm not sure. Create an edge given, what's the information generally? It would be like a from node, a to node. From node to node, assuming you've already created the edges, you're not going to, sorry, assuming you've already created the nodes, you're not going to create any more nodes. You just need to know like the spelling, I guess. Yeah. We'll make this null if there's nothing to put, and we'll make this the pointer to the tree, and we'll do stirred up if we need, I think. And my idea is, since everything is pointers, I don't think I need to return anything. So looking at a particular example, if I initialize everything correctly, then the idea is I have to malloc an edge, then I have to say edge neighbor is equal to the to node, edge, and then the idea is if spelling is equal to null, then edge spelling is equal to this calloc idea. I mean, apparently if I make it null, nothing really bad happens, but I'd rather not have null pointers in case I try to as some weird null access. Else, and this is sort of for the base cases, for the base case, particularly, where is it? It would be the simple expression translate here. Else, don't need to say that, just that. And then edge spelling is equal to that. Fantastic. And then I have to append it to the appropriate place, so it'd be edges append the from node edges. I need to append this particular edge. And again, I believe that because everything's sort of already been created, the mallocs have been done, and I'm just passing the information to this function, I don't have to return anything. I don't think. Okay, so we have a create edge function, and I should also probably have a create node function, really, if I can help it, because like, might as well, right? Create. So create node might need to return something. Create node equals what? Create node given what? Anything? Do I need to do anything? Maybe the num nodes. And it's basically node star node equals malloc the size of node. And then node ID is equal to num nodes dereferenced and then incremented afterwards. And then node edges you should initialize given num edges per node. If this is too small for whatever reason, then the dynamic array header file has like the logic to resize the array if necessary, but I really don't think you need more than 2. But I don't know, I'm a bit nervous. Yeah, and that should be fine. And so, yeah. And then return the node. How fun. Okay, so if I try to use this function, basically anytime I see this being called, that should indicate that I'm trying to create a node. So base start equals create a node given the num nodes. Base end, oh, I didn't put a semicolon. Okay. Base start gets that, base end gets that. This one gets this. You get this, and you get this. Yeah, I really need to get better at recognizing when I can just abstract something away in a function. Like, sometimes I just start writing and I don't think too hard. And I'm like, oh, I could have reduced a lot of repetition. Anyway. And then, so there should only be one instance of this now in the function. Then create edge given a particular from node, to node, and the spelling. So this is a little bit, anytime I see edges append, that indicates that I'm edges. Anytime I see edges append, that indicates I'm trying to create an edge. So obviously in the helper function it's there, but afterwards, okay, so I literally don't even have to, I can say create edge given the from node, which is this guy, given the end node, which is the neighbor, which is this guy, given the spelling, which we said we'll just make it null, and I'll just comment it out for now because I'm a bit nervous. Okay, so create edge. The from node is that guy. The to node is this guy. And the spelling is null because it's all callocked. So that should handle that and that. That also means I get rid of all this awful naming, which is good. And then create edge. The from node is this guy. The to node is the neighbor, this guy. And the spelling is null. Bing, bong, put these beneath. And then same thing again. Oh, sometimes my brain, I should have known to do this earlier. Like I've done this enough where I'm like, I should have known to do this. Just got excited. Finish from node is this guy. To node is the neighbor. Finish edge one, neighbor is that guy. And it's a calloc, so we null. That gets rid of you and all of you. And then create edge. The from is you. The to is the neighbor. And the spelling is null because of the calloc. That's fine. There's a few more. What? From is you. To is you. Spelling is null. Yeah. You are the from. You are the oops. You are the to. What? How have I done that? You are the to. And it's callocked. Pachow. Oh god. What? Oh. From. That's you and you. Then it's you. Base start. Is this the loop? Yeah, okay, that makes sense. Because this is like the skipping edge. And get rid of all of you. Whoops. Almost done. End of view. The end of view to the so that'll get rid of U6 and U2. And finally, create an edge. Given the from node is U, the neighbor node is U, and the spelling is simple spelling. The only time I actually don't use it now. The U4 lines, right? Okay. So just quickly, if I try this again, do you work? 7 nodes, 0 to 1, 1 to 6, 6 to 4, 4 to 2, 2 to 3, and 3 back to 2, 3 to 5, no null, and 4 to 5. Good, okay, so, I mean, that's just one test, obviously it doesn't prove anything, but I feel confident enough that I think I can probably get rid of... Wait, let me try one with an OR. Haven't tried an OR yet. Oh, there it is. I should have tested that earlier. Wait, what? I mean, I figured there's a segmentation fault, but why did it not do that earlier? Oh, okay. So some weird thing where it's not necessarily every time. Okay. Source node is equal to that. Why? What have I done? What have I done? Your source ID got absolutely obliterated. Otherwise, it looks pretty normal. Although there is an 11, which is pretty crazy. Oh no, 11 makes sense, because 9 and 10 somewhere probably. Actually, there's no 10. So maybe this is meant to be 10. But even the source node is crazy. No, it makes sense though. It makes sense. When you do OR, whatever your initial source is, where's my OR? Where's my OR drawing? Here. You know, this would be like your base case number 1, this would be your base case number 2, and then your starting node would be a bigger node, like would be like 5 or something. So like, if I make it simpler, if I do A or B, oops. Yeah, okay. So if I do A or B, what it should look like is the base case A, base case B, so this would be 0, 1, and this would be 2 and 3, and then what would happen is you have this, and this, which would be 4 and 5. And then this goes up here and down here. This goes down here and up here, and these are all epsilons. This is what it should look like. And that's why it makes sense for the source node not to be 0 and actually to be 4. Because the source node got created after the 0 to be over here. So that, in that sense, it makes sense. Why it did that? I don't know. But it seems like... Actually, why are there so many... Yeah, why are there so many nodes? There's no concatenation. Should I print the tree real quick? Make sure that's okay. I mean, I doubt there'll be any problems there, but you never know. Before we do any of that, let's print the tree. What did I call the function again? Parser print expression. My apologies. Print expression given the expression node. Let me compile. Oh, sorry. My bad. Yeah, that should be better, actually. But anyway, it's fine. That compiled, right? Yeah, okay. Let me try... Yeah, it looks pretty good. A... So my claim is there should only be 6 nodes created, but it's creating 9, so that's intriguing. Sub none, so A or B. Oh wait, I think it's like, sorry, the new line's being counted, that's why. Now it's 6 nodes. Okay, sorry, that was silly of me. A or B or nothing. Good, okay. I was like, what's going on there? Yeah, it was like B concatenated with like the new line concatenated with nothing, and then the OR. Okay, yeah, that makes sense. Okay. So I think it's creating the nodes correctly. I think it's just losing track somehow of... Do I do that? Compile it again. Yeah, so sometimes it even crashes, sometimes it doesn't. I think if I use a sanitizer, it probably would crash every time. I'm always a bit reluctant because sometimes the printing, when you use a sanitizer, sometimes the printing gets really weird. I do not know why. Anyway, let's think about what's exactly happening. You have the source, the base. I'm going to assume the base cases look good because the base cases do look good. 0 to 1 is A, 2 to 3 is B. That's the 0, 1, and 2. Like the base cases seem to be running correctly. From there, what would happen is it's done that. Then the expression, in the translate expression, it would see that, you know, it wouldn't run this line because expression or is empty. It's not empty, right? It's full of stuff, full of a B. So we would continue running. It translates the OR, it does that, and I'm pretty confident it does that correctly. Then the base, which is the NFA base, gets malloc. Base start, we create a base start node, which I'm pretty confident this is a good, like all I did was copy the exact same code that I've been writing all the time. So node star, malloc size of node IDs, num nodes, which is that guy, that almost global counter that I'm using. Increment it, node edges. That's just initializing the edges array. Not actually creating any edges, just initializing the array. We create the node, We're creating the start and end node. That's this guy and this guy. So for whatever reason, you're massive. I'm going to make the assumption that the issue doesn't happen in this function, because it doesn't seem to happen in the base cases. I don't know why it would happen here. And it only really seems to happen to the source node. The finishing node gets the correct number, it gets the 5. So I don't think it's this function directly that's causing any issues. I'm just wondering if I did something a bit silly at the end. We create an edge. Again, even the edges look good. Like if we imagine this said 4, I feel like this would be correct. Node 4 to node 0, node 4 to node 2. And then node 1 to node 5, and node 3 to node 5. Like the actual edges and the graph seem to be correct, but it's crashing because I seem to be accessing, I'm assuming it's some kind of access. I should have tested this before I made the code changes, because then it'll be easy to know if the reason why this happened is because of the code change or if it's because of something more inherent. I don't really want to change. Nah, it's better code if I write it like this. So let's just pretend I never did this in the first place. Let's just scrap all of this excess, all of this verbosity, and just pretend that I wrote good code from the start. I wonder if, okay, let's try a sanitizer. I just think that it's not gonna, I don't know what I'm doing. I will use a debugger, worst comes worst, but how do I use a sanitizer again? fsanitize equals address, and then run it. Bam! There we go. So what happened? A heap buffer overflow, which means what? You're trying to write something that caused something to happen. Oh, I'm so bad at using this thing. All right. Is located 0 bytes. I've never been good at reading this stuff at all. Heap buffer overflow on address that at the process counter or program counter or something. BP ultimate and stack pointer. What is B again? I should know, but I don't. This guy's located 0 bytes to the right. So you're trying to write on this address, but it's like, is that what's happening? You're trying to write wrap malloc. Yeah, I don't have to read any of this. 1 shadow byte in the shadow realm. Okay, we'll use a debugger. I don't know what's going on. I tried to be a big man, but it didn't work. Let me get rid of the sanitizer then. I'll just do the -G. All right, let's put a breakpoint. I truly believe that the error wouldn't happen before me doing the base cases. So I think in translate expression, if I put a breakpoint here, or maybe wait. No, that doesn't make sense. I was gonna say maybe I never wrote, because base start, the create node function is responsible for adding the node ID. Oh wait, no, that's dumb. I was gonna say maybe I did something dumb, but I mean I have done something dumb, but I don't know. It's not what I thought it was. Node base start equals return a node that is malloc like this. You set the node ID to be num nodes, which is this guy. Sorry. Yeah, right? Like, it's this pointer and stuff. What is happening? Alright, we'll do this. Bong. Oh, my bad. I have to do all this nonsense. Okay, how do I... Workspace folder, not matching. I want not matching. What is this folder called? This directory is called NFA construction. And NFA construction. And then a.out is the thing. The arguments are simply A or B. That is my argument. Stop at entry will say false, and I don't need an external console. Okay, so try that again. Sure. Okay, so what do we have? We have the subtranslate, which has 2 nodes in it, which makes sense because it's the base case. The or translate should also have 2 nodes in it. Oh, so I was wrong. Really? Okay, so that explains why. Okay, so I was wrong. I need to do this again. I need to put a breakpoint right here. Okay, wait, let me stop. I need to put a breakpoint right on line 84, and I need to do this whole thing again. Wow, I was so confident. I was like, wait, what? Do I have to compile it again? What do you mean it's newer than module file? Okay, I can compile again. I don't mind. Wait, I didn't even put the... Hang on. I didn't put this one. All right, jump in. If the OR expression is empty, it is not. Then we're going to translate the expression. If the sub is empty, it is not. And then num noticed. Okay. Oh god, this is where things get awkward. So sub expression, if it's empty, it is not. We're going to translate the star expression. So I must have just forgotten to put like... I don't even know what's happened. Simple. It's an escape char. Sorry, it's a single char. We malloc. We create the node. We create the node. Create the edge. To make the base case, base num nodes is equal to 2, return the base. Num nodes is equal to 4, which tracks because we did the 2 base cases at this point. If it has the star, it does not. Return that simple translate. Just that simple base case, nothing crazy. If it's not empty, it might be empty. Yeah, it is empty. Return the star translate. That's the B, I think. That's the entire B. If expression, this might be, yeah, okay. So we've done the whole OR expression. That's the B. Okay. What? Where's the base? Base. Why did you do that? Why? That was never a weird number, right? That was 6. That was 3, and then that was 4, then 5, and 6. Why were you... What? What is happening? Oh, wait, unless maybe... You know what could have happened? Maybe. Well, actually, I don't know. I was gonna say maybe because I said num nodes like here and here, like maybe there was like some weird confusing, like I accessed the wrong memory or something. You know, like it tries to access something random. But I don't know why it would do that. I can though, what I can do is I can change this name for, because I don't think I use this as often. I can say this is size or something. I don't think this makes any difference, but I just want to cover my bases. But I just don't see how this would happen because these fields are scoped, like they're scoped by the object that you're referencing. So but alas, unless my hand just like slipped and I actually have like a billion written somewhere in my code, but I don't think I would have done that. Alright, let me compile it real quick. Let me run it like in here. Yeah, no. Okay, I do prefer the field name num nodes, but I'll just keep it as size for now, just so that doesn't... I don't even think about that as a bug. Do I really have to do it from the beginning? I really don't want to. Kind of hungry. I've been working for like 4 hours, haven't I? Did I start at 9 o'clock? Surely I started a bit later than that. Doesn't feel like I've been working for 4 hours. Although time does fly when you're having fun. I'm very confused. Num node starts at 0. Okay, we're going to keep a very close eye on this on this variable. It is not empty. We're going to translate the sub-expression. I'm going to skip that. That's basically just getting the A. And we see that becomes 2. The sub translate has a size of 2. The start has an ID of 0. The end has an ID of 1. That is fantastic. Then we do have an OR, so we won't do that. We translate the OR expression. Again, I am going to skip that. Oh, wait, what? What did I just do? Did I click the wrong button? Did I click down instead of... Okay, I think I just skipped it, right? Num nodes has increased to 4 because we just ran this and there are 4 things. The sub translate still has a size of 2. The ID is 0. The end is 1. Fantastic. The ID of end is 1. The OR has a Okay. So it's definitely the OR. Okay. It's definitely running that because there's no way, like the OR is not empty. If OR is empty, and I make sure if OR is empty, I return. I don't run this function. So at this point, I know OR is not empty. So there's no way this runs. It runs this again with OR expression given the num nodes. Given the total number of nodes that I have been given. And then we run this. The sub-expression is not empty, so this will not run. Translate the sub-expression. And then the OR at that point should be empty. Translate the OR expression. What? But why is it messing up here in specifically the OR section? Like if it was a problem with the translate sub-expression, surely this would appear multiple times, you know? Clearly I'm accessing garbage. Clearly. But the thing is, the way I set the ID, there must be a point. But if I create a node, I set the ID. Like, this function sets the ID. So how am I using garbage? Unless this address is garbage. But how could the address be garbage? I'm using the same address every time, right? I don't even know where to look. I can't even imagine what would be doing this. Normally I have some inkling, oh, I did something dumb, so therefore XYZ. I can't actually think what I did silly. All right. We will specifically pause it on the OR expression. We will run this again, and I will work systematically. I will access this. The num nodes is still 2, which is fantastic. That is exactly what we expect. This isn't empty. We will access this. Num nodes is still 2. Good. It's not empty, so we'll go in through here. We will check the sub-expression. This is the OR sub-expression, so this is the B. If it's empty, it is not. We will translate the star expression. We will translate the simple expression, which is this. We will malloc a base. We will create the start node, becomes 3. We will create the finish node, becomes 4. We'll create the edge, that doesn't change the thing, and the base's size becomes 2, because it's the base case. Then we return. Num nodes is still 4, which is great. Simple translate we've just done. If it has a star, it does not. So we will return the simple translate. It's still 4, right? If the sub is not empty, if there is another thing to do, if there is some concatenation to do, there is no concatenation to do. So we will say else. We will return the star translate. It still says 4. Translate the sub. So that's after we've already done the OR. And then this will happen, which should return. Yeah. What? Am I, like, really dumb? Wait, I just did the OR thing. Now nothing bad happened. Am I tripping out? Isn't this I thought this was where the error was. I thought this is where the garbage thing happens. It makes sense that this is garbage because I haven't set it yet. Right? That makes sense. It makes sense that that is garbage for now. It makes sense that this is garbage because I haven't done it yet. It makes sense that this is garbage because I haven't set it yet. That's all fair enough. But what? Now the base start is equal to create node. So this should become 5. It does. The ID became 4 on the base, which is this guy. This is the 4. It changed. When I... Huh? Excuse me? Why do you have to... Why do you... Wait, what? Okay, so I was right. The OR expression is fine. It's here. It is here. I create the node, and it said ID was 5. We all saw that. I'm glad I'm recording. We all saw that it said 5. And then I got this one. What? Base start is create node. Unless, did I say node? Node ID is it's a straight integer. I'm just writing it once and then I'm never touching it again. Why are you modifying? I'm trying to think like somehow this thing is pointing to this one, so then when I modify it, it gets shifted. No, but am I somehow like changing? No, that doesn't make sense. I'm making it set to an integer. I'm not setting it to an address. So I feel like I'm somehow changing what address it's pointing to. That's the only way I can understand why this is now pointing to garbage. Because like, what? What? What is happening? And it's doing it consistently as well. It's doing it every time. So something very specific is happening, and I have no clue what it is. It's like it's overriding over the numbers that I. But. Wow. Base start create node. Base end create node. When I figure this out, I'm gonna have some mega understanding of everything, because like this is some crazy bug. I don't understand. Like there's no there's no reason for you to touch this guy, right? Ba- Unless base start is equal to base end, but no, I'm making it so that they're not. I'm saying that base start is this create node, which is a malloc, size of node, node ID. I'm trying to think if somehow like the nodes are colliding with each other. Like, the OS is like, okay, you take this memory for this node struct, and then when I call it again, it's like, okay, you take this memory, but then somehow like they're like overlapping or something, which is why they're interacting. Like, I don't get at all what would be causing this to happen. If I just make it so that if I just say, look, I'm going to dereference you, and then num nodes plus equals 1. If I just write it separate so that all I'm doing here is I'm accessing the number. Like, this node ID refers to this node in this scope. So why did that guy? Okay, anyways, let me put the breakpoints. Let me yeah, so that breakpoint. Let me run this again. Oh yeah, I should compile it. Sorry. All right, do that again. All right. Number of nodes is equal to 4. Or translate size of 2. Start has an ID 2. End has an ID of 3. Subtranslate, start has an ID of 0, end has a translate of 1. Fantastic. I haven't created any nodes yet. I create the base. Base is created at this address. The size is 0. The start is nulled out. The end is just some random thing, right? It's 8 bytes big because NFA is... Wait, it's 8 bytes big. Is that weird? Oh no, because of the limit. Oh, wait. What? I was gonna say it's 8 bytes big because it's a pointer, right? Like NFA base. Oh wait, have I done a silly? Wait. Is start and end reserved or something? Like for... Is start and end like reserved keywords for the start and end of a struct, like addresses? Am I modif... Okay. I have a weird sinking feeling that start, if I rename it to, I don't know, initial, And end, I call it, instead of end, oh, it's gonna be more annoying. Okay, I shouldn't just find her. Okay, if I call this initial and then let the errors come, and end is, I'll call it terminating, terminal. So yeah, initial, terminate, terminal, initial. If this is the reason, this is the most insane thing. Like, I get it because, but am I guess because yeah, the way that C works under the hood might be, I don't know exactly if this is correct, but it might be that every struct inherently has. The more I think about it, the more I doubt myself. I don't think this is correct, but I just can't think of what else. Because the fact that it has start and end, but the start is 0 bytes up to 7 bytes. Like, it shouldn't be 8 bytes big, right? This, like, I have a, like, I'm pretty sure this is a 64-bit machine. So this alone should be 8 bytes. This should be 8 bytes. And then this should be a 32. This should be 4 bytes. So there should be 16, 20 bytes anyway. I think. And then, even if this was 32 bits machine, which I don't think it is, this is 4 bytes, 4 bytes, 4 bytes, 12 bytes. It shouldn't be 8 bytes. So that's the only thing I can think is, like, I've managed to snipe the field names that are exactly the same for indicating how big the struct should be. And I'm like actually modifying that field instead of just simply, I don't know, I'm like, this is such a guess. I'm purely basing it on the fact that the size doesn't look correct. I have no other ideas because otherwise it makes 0 sense. All right, let's try this again. Okay, so number of nodes is 4. Or translate has ID 2 at the start and ID 3 at the end. Five. The base's initial becomes 4. Okay, it didn't work. Okay. I'm glad that's not the reason, because that would be the most insane thing. But I'm still stuck on square one. What's causing it to change its value? I still think that the fact that it's 8 bytes is suspicious. I don't get why that would be the case. Because we're saying base. I'll go for another like 10 minutes or something, and then I'll take a break because I don't think I'm getting anywhere. Base initial. I don't even know what I'm looking at anymore. I'm just staring at code. NFA base. Where are we? I'm over here. So NFA base. I have the address. I have the initial node. Right? That's what that is. The initial node. And its ID got kind of messed up. I have the terminal node, which has an ID which didn't get messed up. Got set to 5. So why are you pointing to garbage? Maybe the only thing I can think of is like from memory, you're supposed to put the bigger fields ahead of the smaller ones. I kind of forgot about that, but Like maybe there's some weird alignment things happening. But I mean, I feel like that can't be the reason. I'm really pulling at straws. Like I just can't think what would be causing it. It's some weird low level thing is the issue, and I'm not great at that. So base initial terminal. The size is 7. ID is 4. Oh my god. Is that what it is? Yeah. Okay. Wait. Let me think. So, okay. I need to look at memory alignment. Okay. So, all I can remember, I read this in a book once. That's why I know it. The bottom line is that the good practice is when you make a struct, you should put the big fields, 8 bytes, 16 byte stuff, whatever, at the top, and then put the smaller stuff beneath it. Chars and ints and stuff, put it below it, and do it in descending order, because when stuff gets written in structs, the compiler or the OS, I don't know who does it actually, but someone's trying to line up the fields along boundaries, the word boundaries, right? 64-bit machine means 64-bit boundaries, 8-byte boundaries. So when you try to put an integer ahead, what is happening? When I do, because I assume it would have been this, right? Let me just compile it again. That's garbage, that's fine. And then you run it. Size of 8 sounds a bit wrong. Oh, okay, I guess that's also just garbage. Create the node. Wait, so what am I looking at? These two guys. This didn't even change. So what? It was the other one. It was this. So the base has initial and terminal. The initial originally is okay. Then the terminal looks like that, and then okay, so it's that alignment. So it's this. It's not even the ID. It's the size and stuff. So the NFA struct, if I defined it using size first, which is 4 bytes, and then the node terminal, the node initial, node star initial, which is 8 bytes, and node star terminal, which is also 8 bytes. Then in memory, it looks like a 4-byte block. And then my understanding is this 8-byte block thing will like pad 4 bytes. And then do 8 bytes. And then do another 8 bytes. For the 2 pointers. So like, this is from 0 to 4. This is from 4 to 8. This is from 8 to 16 or something. And this is from 16 to 24. So this is what the struct looked like in memory. So when I tried to access, when I tried to do what? What did I try to even, what did I even do? That was so crazy. When I tried to create a node, I created a node in memory. I had num nodes in memory. Node ID. It's a lot of weird interactions. So this was an address which would have pointed to an actual node object. Where a node object I just confirm something. If I had this in the correct order and I compile it, does the bug still happen? I just want to double check. I forgot what the actual results were. So bing, bing. No. So both of them have to be misaligned? Is that what we're saying? Like, if you are misaligned but you are okay, then the bug doesn't happen. I think. I did compile, right? If you are misaligned but you are not misaligned, what happens? Bing. Seems like it didn't happen either. So only if they're both misaligned, is that what we're getting at? Okay, I'll bear that in mind. They both have to be misaligned for them to not play nice. If one of them is misaligned, I guess. Alright. At least we fixed that bug, I assume, I hope. If I just run the code as normal. Oh wait, I have to actually fix it, sorry. Let me do this alignment stuff properly. I'll admit, I forgot about the alignment stuff. I think because in my mind, I was like, oh, I need to like remember to put in the right field. So I just remembered to put the size and the ID. And then that was just the order I remember things in. Bit harsh, but fine. What? Now what? Okay. I thought I'd fixed it, but apparently not. So it's starting to print, because saying source node equals that. So you're telling me that this way I had now I'm so confused. You're telling me when I have the misalignment, it prints, it's completely fine with it. It just has some weird overriding bug thing. But when I do it the way that I'm supposed to, it doesn't even get to the print statement. Is that what we're saying? Oops. What? I'm about to pass out. What just happened? I swear. Is it? Did I forget to compile? What did I just do? But it was completely different behavior. It was saying the bus error. Yeah, okay, so there is something. Wait, what's causing it to change behavior? Let me, I don't know, I can try the sanitizer again. Hopefully it's something different. Whoops, sorry. Address. Okay. Looks exactly the same. Located 0 bytes to the right. It's the exact same error. But it doesn't even let me print. So maybe the original bug wasn't even the fact that the ID was written weirdly. Maybe it was something else. Oh my god. All right, let me check one thing. If I don't use the or, if I just say like AB, is it fine? It is. Okay. So it truly is like, what if I do AB star? It's truly the grouping, right? It's truly the, when I add a thing. Okay. Okay. At least that narrows the cases or something. I don't know. What if I, instead of address, what if I say memory? Is that better? Is that like a better sanitizer for this? I don't know what the difference is. Memory is specific for leaks, right? What are the types of... No, I think leaks is a particular... Yeah, that's not a thing. Undefined or something. It's behavior. Behavior sanitizer in C. Undefined. I just want to see if this helps at all. What? There we go. Okay, just want to see if the thing is any more. Seg V. What does that mean again? Am I reading a null? Wait, it's caused by a read memory access. Why is this guy saying it's a write thing then? Oh my god. Anyway. Oh, he even gave me a 9. Already it's a bit nicer. 217. Oh. Don't... 37 specifically. The size wasn't set correctly? Don't tell me that's what it is. No, but size isn't... Size is referring to the memory, like the... Size is referring to the edges size, like the dynamic array. It's not talking about the size like this size. The signal is called by a read memory access. Yeah, I can't provide any more info. Note, the pointer points here. Memory cannot be printed. Load of misaligned address. But I thought I fixed the alignment. I guess that's not what that means. Oh, unless it's the same issue here. I mean, I'm pretty sure that's fine, right? Size of T is unsigned long, which is 8 bytes, isn't it? A long is 8 bytes, as is a pointer, so in that sense it should be fine. I mean, I can switch them around just to see if that does anything, but I don't think it will. Oops, sorry. Undefined. Yeah, I didn't know. Member access. Okay, this is giving more information. Like, if the other sanitizer said something about misaligned addresses, I would have thought about this a lot faster. Member access within misaligned address for type edges, which requires 8-byte alignment. So what? I'm supposed to align the memory? I thought that was your job. Why? Why are you mad at me? Everything's divisible by 8. Oh, I guess that's not. But most things are divisible by 8. Why are we mad at me? I mean, yeah, the fact that it's referencing it's referencing the dynamic array. So I guess my dynamic array library is wrong. That's kind of crazy to me. Unless I'm accessing it weirdly. Hmm. It's so weird though, because it's specifically for the OR we said, right? Like we saw that it didn't really have a problem if I didn't use the OR operator, but if as soon as I chucked it in, it was causing problems. But if it's about address issues, then why would the fact that it's the OR operator make any difference? There's all these weird clues, but nothing's really lining up. Like nothing's really. All right, I'll look at all the variables. So we know that it's sort of at the DFS. So if I make a breakpoint up to, whoops, I'll stop this. If I make a breakpoint up to here and cut out all the other breakpoints, just try it. Let's just see what the thing looks like, you know? Pause on the exception. What? Already? But I thought we were fine until here. Like it printed number of nodes created. It printed that, so I thought that was safe. Guess I was wrong. What if I pause it here? Do I have to compile it again? Oh, I didn't put dash G. Sorry. Okay. All right. So here it prints that it's happy. Number of nodes created is 6. This looks good. Everything looks pretty good. Regex is A or B. The expression has a sub. Is empty is false. The star simple spelling is A. So that's the sub. Then the OR is false. Expression, the sub is empty is false. The sub is empty is true. Sorry, I looked at the wrong thing. Star simple spelling is B. Good. So the tree looks pretty good. Number of nodes created is 6. I should have my NFA with the initial with an ID of 4 and the terminal with an ID of 5. Remember that we're drawing, we're trying to create this graph. So initial of 4 and terminal of 5 looks good. The edges, wait, what? Did I forget to initialize something? Wait. Why does that say? When I dereference data, I get null. That doesn't make sense, does it? I shouldn't get null. I should get like just some empty array. Oh no. That makes sense. It does make sense because like the capacity is 4, but the size is 0. I haven't actually put anything in there yet. So when I dereference data, it's empty. So I guess it's null. I guess they fill it with null. My head hurts. Okay, but everything looks good is the issue. Like the state, in terms of the state of the program, got edges. Whoa, that doesn't look good. There we go. That's something crazy. What the hell happened to you? Your edges. What if I just change you to int? Trying to be clever. Saw this on a YouTube thing or something, but what if I just change you to int? Then what? Will you play nice? Put you beneath. And I compile. And I run it. Did it work? Let me put it with the sanitizer. Oh. Oh my head! What is happening? Alright, I'm gonna stop. I don't get anywhere. I'll look at it another time. We're almost there. It's like clearly we're close. It's just really doesn't like me today. Member access with misaligned address. I guess that does look like a weird address. Like you should be divisible by 8. Why are you being put there? But that's not my decision. I didn't put it there. Like you put it there. Like do the padding thing, man. I might have to. There is a. I think is there a alignment function in C? I've never had to do this before. I have no idea what I'm doing. Expected a semicolon. Really? Why? Because of that? I think I'm just using it wrong. Okay, I'll need to look into it. All right. That's all right. We'll stop. I gotta eat anyway.